Welcome, everyone. This is Michael Gibbs, and we are back for day 3 of our AWS Certified Solutions Architect Associate 2024 program to help you pass the AWS Solution Architect certification. And this is an AWS full course tutorial, and this is our summer version of our free certification course training online. So we're here again, and I'm excited to be here, and I'm thrilled to see all of you. So tell me where you're from. Let us know in the chat box. I am in South Florida today, and I'm enjoying the very hot weather that we're getting this summer. Went outside this morning, and it was so sunny. It was kind of nice. So let me know where you're at. Before we begin, I want to remind everyone that, we're going to be focusing 10 days, 3 hours plus each day to cover the AWS Solution Architect Associate Certification with TLR, and we're going much deeper. We'll get into many of the things from the AWS security certification. We've been covering some of the things already from the AWS Advanced Networking certification. We have some new AI machine learning things in there because they're going to become more and more important. So we'll be talking about them as well. And, we do have over 40 labs for you to get hands-on, and I want you to get hands-on. So please sign up and register for the free labs and go do them when you have a chance. So I definitely want you to get that. And I also wrote a certification guide. It's an ebook that our team and I wrote on certifications that will help you in your career, especially if your goal is to be a cloud architect or a solutions architect. I have to tell you, I see some resumes sometimes and they're terrifying to me because people worked so hard to get certified and they learned 14 different people's careers, but they never learned their own. And it's kind of sad. Because it's hard for them to get to their goals. So I want you to go and know what to learn and when to learn it. So go get that certification guide. Let me see where you're all from in the chat box. I'm seeing San Antonio, Texas. I've spent some time there. Austin, Texas. Fantastic. Nigeria. Love that. We've got lots of wonderful folks from Nigeria, most likely here as well. We have people from Calgary. I did a lot of work in Calgary with, was it TELUS many years ago? India. We have lots of people there. Adrian Griffith, you're in Barbados. That's about as beautiful as it gets. That's a great place to be. I haven't been to Barbados in a while, but I've always loved it. George in Miami, we're probably pretty close. I'm curious where you're actually at. I used to spend a lot of time in Southwest Miami by FIU many years ago in my youth. Really great place. Tend to love it around there. Let's see where else you are all from. Phoenix, Arizona for Adrian. Fantastic. Bo Fa in Bo, Cameroon. Fantastic. We have Eddie who works for us in Cameroon. Anna Marie in Argentina. Haven't been there in a while. And Aussie in the UK. Fantastic. I used to actually go there almost every week for work. And Dover, Delaware. That's an area I know real well. I actually did 2 master's degrees at Widener University just over the line in Pennsylvania in Delaware County. So spent lots of time in Dover, Delaware as well. Alvi in Karachi, Pakistan. That's fantastic. Always wanted to go there. Never managed to get to Karachi for some reason. Work just never got me there. I have to fix that somewhere along the line. And yes, and Sacramento for Preb. It's so good to see you out there. And Miguel in Miami. Well, we should start some Miami contingent here. And Samuel in Lagos, Nigeria. That's wonderful. Batu in Boston. And Satya in Philadelphia. My wife is actually in Philadelphia. We keep a house in near Nazareth Hospital because a lot of times we go visit our family there. And Rick over there in Tunisia. Wow, that's really fantastic. I love this. I love when we get so many people to come together from all over the world. And that's the whole point of doing this, to build a community, helping people get to their goals. I see Mexico. I haven't been to Mexico in a couple of years, but that's fantastic. So please give me a hashtag AWS so I know you're awake, alert, and oriented. And then we're going to begin. We have an ambitious agenda. We're going to go for 10 days straight. And after that, we'll probably do some free hands-on mentoring sessions with you as well, because we want you to get a really great experience here and learn as much as you can. So we'll go for approximately 20 minutes, 30 minutes. We'll stop for about 10 minutes of questions. The goal is to do 20 minutes of questions an hour if you have them. So we will begin as soon as I see those hashtags AWS popping in. I see the first one from George. Thank you so much. And Adrian, wonderful. Now I'm seeing them coming in. Lots of my hashtags AWS. So I know you're awake. Ebenezer, so good to see you in New York City today. And Tundi, fantastic. Rick. So, okay, I will get back to the content now. So welcome, everyone. So we're going to begin by discussing Global Accelerator. And Global Accelerator is an AWS service that improves the performance for customers regardless of where their location is. And what it does is it tries to get you to move traffic over the AWS global network as opposed to taking longer to the internet to get there. If you'll recall, I said on the first day that internet bandwidth is not guaranteed. What happens when you send your traffic to the internet is, let's say you leave AT&T and your website is, and say that you're going to is in Japan. So AT&T may connect to British Telecom, and British Telecom may connect to Vodafone, and Vodafone may connect to NTT in Japan. So you could literally go for 4 or 5 or even 10 or 15 internet service providers to get to your end destination. And while your internet service provider has to guarantee you what you get to them, it doesn't have to guarantee that through their network or even on any other network. So if you're on the internet, you're not going to get the same kind of performance you would get as if you were on a private network. So that's why organizations build their private intranets. That's why they get things like direct connections versus a VPN, because they need guaranteed performance. So what's really going on with Global Accelerator? And there are really two types of acceleration. There's going to be standard acceleration. We'll talk about what this is in a minute. And that's going to make your application available and work well for users that are going to be globally. And what it'll do is it'll send traffic to the newest region. And where does it actually send the traffic to? It typically speaking sends the traffic to the nearest edge location. And what is an edge location? It's an internet point of presence where you've got your content delivery network and all your internet service providers are in the same building. So hopefully that makes sense. And now we're going to talk about a custom routing accelerator. And here's where you choose where to send your client traffic. For example, maybe you want to know which server to send your traffic to amongst various options. So how does this work? Well, AWS is going to have 110 points of presence across 50 countries. An internet point of presence is basically where you've got 50 internet service providers that all bring high-speed connections into a building. And they put their switches in the building. And then when you want to connect from, say, AT&T Verizon, because they're all in the same building, all that's necessary is to run a fiber optic cable between the two provider switches. So by putting all your internet service providers in a single building, they can connect to each other's switches via something called the cross connect. And that way, they don't have to have connections everywhere. You just connect to these 100 locations. Every internet service provider, for the most part, goes into these 100 locations or much like that. And then poof, you just run cables between them. So I kind of hope that makes sense. So the way that's where you're going to be coming into. So when you use AWS Global Accelerator, you're actually going to advertise 2 public IP addresses and 4 if you're going to use IPv6. We'll talk about more how this is going to work. So how's all this stuff work? So ultimately what happens is the IP addresses from these edge locations are going to be advertised into the global BGP routing table. And then it's going to use Anycast to find the closest locations. So each client will reach its normal edge location by its IP address. Now, Anycast gets people all kinds of confused. I talked a little about Anycast a little bit when I was describing DNS, but Anycast is used in a lot of different things. So we might as well actually what kind of whiteboard this out. I really want you guys to really understand this. So first, let's talk about what an internet point of presence actually is. And I can show you what this is. Because without this knowledge, like unless you were a network engineer, it's just going to be hard to understand. So let's say this is your internet point of presence. And what'll happen is you'll see a router coming in over here. And let's say this could be NTT. It's a fantastic phone company that's in Japan. This could be Telefonica in Spain. Another great, what do you call it, internet service provider. In the US, we have, say, AT&T. We have, say, Verizon. And what happens is all these internet service providers and more, they have wide area connections that go back to their own networks that connect to obviously routers on their domain. So you've got all these devices that are sitting in here. And when you want to connect two of these devices, because they're all in the same building, it's going to be the coolest thing ever. All you have to do is you just run a cable in between these things, and that's your cross connect. Want to connect AT&T to Verizon? No big deal. And that way, systems from the Verizon network can connect to the AT&T network. You got a cross connect. Want to actually connect Verizon over to Telefonica in Spain, which is coming out of Spain? No big deal. You had a cross connect. And this is what these kind of environments are going to look like. There's going to be lots of internet service providers. Now, it may not just be a wire. They may bundle multiple wires in a link aggregation group. And we talked about link aggregation groups. And obviously, of course, they're also going to be, well, it's not going to go well. But the point, they're also going to be coming like this. But the point is that everybody's going to be connected to anybody that actually has a cross-connect agreement. And that's how these buildings actually are internet point of presences tend to work. So now that you understand that, that's where these internet point of presence comes. Let's actually talk about, the way this Anycast is actually going to work. So let's say with Anycast, we advertise an address. And the address we're going to advertise is 1.2.3. Actually, let's not use a public address that could actually be used. This is a 10.1.1.1. We're going to use a private address for this so we don't accidentally publish somebody's public address. So, and this is really where you're going to jump onto the AWS network. So let's say you're going to have this that'll be advertised by the Global Accelerator. You'll also have another one of these on the Global Accelerator. And in between this stuff, you're going to have actually, let's move this over a little more. And in between these systems, you've got the internet. So what'll happen is you're going to have this is your user. And user's going to have this same IP address in two different places. The user will not see both places. The user will go to the router, and the local router will determine which one to get to. So that based on whatever BGP is telling this router over here, this router will know whether to go here or whether they should go here. Now, if this were to just disappear, goodbye. That wasn't supposed to happen. If this thing was to just disappear and it went away, the router would see the route in the routing table to this. So realistically speaking, this is what's going to be going on. But let's add a little more for you to really truly get this. And then what'll happen is once it jumps onto AWS, AWS is going to have their own routers. And they're going to have their own routers, which are going to have then their own links, which are going to go back to their own network. But the point is this is the private network back here. And all this stuff out here is the internet. So that's how the background of this internet routing is really going to be running. So you can also look and see where these points of presence are. You can see they've got them for the most part in most major cities or most places that you need to be. So you'll post an address, and this address could be advertised all over the world. And if you're in Sydney, you'll pick up the location that's in Sydney. If you're in Argentina, you'll pick up the one that's in Argentina, or vice versa. And if that's not there, you'll go to the next closest one, because that's the way Anycast works. It's a way to provide better internet routing and high availability at the same time. So what'll happen, the client's going to reach the edge location, and AWS Global Accelerator will use your load balancing setup that's going to send your traffic to one of your resources. And that could be a load balancer or a virtual machine, but it's going to use that private network that I wanted you to see. That kind of stuff's not even talked about in the certification, but if you don't understand it, you won't be able to understand how it works. So I wanted to kind of cover that for you. And your traffic is going to be directed based upon the kind of accelerator you use. So with the standard accelerator, you can improve the availability of your internet applications that are going to be used by a global audience because you've got lots of places to jump on and you've got that multiple endpoints with the same IP address. With the standard accelerator, with standard accelerator, global accelerator will direct your traffic over the AWS network to endpoints in the region that's nearest to your clients. But the traffic is going to be based upon the accelerator you use. If you use the custom routing accelerator, it allows you to choose your own application logic. So you can route to either multiple users, a specific virtual machine, or an EC2 instance, and you still get the benefits of Global Accelerator. So when you need custom routing, it's going to be perfect for applications that are going to require consistent servers. Online games are an example where you'd want to be on the same server each time. And so why would you use Global Accelerator? Well, because it's connecting you directly to the AWS network through the internet at the closest point of presence. And because it's going to use its private network, once you reach that point of presence, it's going to give you better performance. It's going to give you lots of flexibility, and it'll give you the ability to maybe load balance your systems via Anycast, where it's actually sending users based upon the part of the world to a different location. So I hope that answers the question about Global Accelerator. Now, let's start talking about storage. If we're going to have a cloud, we need obviously the network because the cloud won't work without the network. We're going to need compute, something to do the work, and we're also going to need storage. So let's talk about storage. So we'll begin with what is storage? Storage is where the data is. And there's going to be two kinds of storage that we need to talk about. There's volatile storage. If the DRAM in your computer is volatile, and what do we mean by that? When you shut your computer off, whatever's in the DRAM is no longer there. But when we deal with cloud providers, the storage on the virtual machine itself, that instant storage that it comes with, is both very fast compared to block storage, but that's neither here nor there, but it is ephemeral or it is volatile. So you create a virtual machine or an EC2 instance. You delete that virtual machine, all the storage is gone. And there's lots of times where you may want to delete a server, but not lose all its data. So we have to use some form of non-volatile storage. Non-volatile storage, for example, is your hard drive. Now, it can be slow or like a slow magnetic drive. It could be medium speed like a standard SSD. It could be high speed storage like an NVMe SSD drive. But whatever the case is, storage is either going to be volatile or non-volatile. Now, when it comes to non-volatile storage that we're going to use in the cloud, guess what? It's the same three types of storage we've used for 30 to 50 years. Block storage, object storage, and file storage. This is nothing new. The names are going to change with the cloud provider, but it's standard data center storage. So we'll begin. What is block storage? So block storage is a type of network-based storage. So first, it's accessed over a network. So when we talk about block storage, it's accessed over a network. This is very important to know. If your network speed is 1 gig, you can't get faster than 1 gig on block storage because it's not in the server. It's accessed over a network. Now, what happens is you take the data, and the data comes in, and it gets broken down into blocks. And each block is going to have its own unique block identifier. And the blocks will be placed anywhere on the network, wherever it's most efficient. So I want you to think about this. And why do organizations like cloud providers love block storage? If we can take the storage out of the server or decouple the storage from the server, and we can store it anywhere we feel like on our network, we can scale. Because now the servers are no longer limited by the number of hard drives you put in them. Hard drives are somewhere else. And what these storage area networks look like is they're going to see these giant boxes filled with hard drives with RAID arrays, and we'll talk about RAID. and there's all these servers in there. So you need more storage. What do? You add another machine, plug it into the network, and you've got more storage. So it's incredibly scalable. So that's why I've been using block storage in the data center for about 20 years. And that's why when we go to a virtual data center like the cloud, they're going to be using block storage. So keep that in the back of your mind. Take data broken down in blocks and it's stored that way. So the next type of storage we talk about is object storage. So let's say, object storage is another type of storage area network, but it's a little different. With object storage, we take our data and it gets broken down into an object. Now, when the object is stored, it's kind of just dumped into this environment. But what happens is when the storage is just dumped into there and it's got an object unique identifier, there's something that's very database-like that says, Mike's picture, Cindy.jpg, is in this location, in this storage environment, this register, what have you. So it's very database-like. So when you look at object storage, even if we make folders and things like that, and it looks real, then, we have to understand that, it's going to be an object and it's not going to have any hierarchy. It's going to be flat and it's very database-like. What makes object storage so special is the metadata. So what is metadata? Metadata is data about data. So when we're dealing with object storage and we have an object that's got an identifier, and then we've got something that tells us what's actually in that object, now we've got lots of options because we can query that data, metadata, we can search it. We can look into an object and say, I only need this 10% of the data and reduce the load on the network, for example. At the same time, we can put in a big data environment, and because we have data about the data, when we catalog that data later, all kinds of things, it gets really good. But you have to remember, object storage isn't normal storage. You're not going to mount it as a hard drive on one of your virtual machines or EC2 instances. It is different storage. It's what you call worm storage, which is write once, read many times. And here's the reason. In traditional object storage, and AWS and the cloud providers will try to modify that to make it feel more like normal storage for you. Every time you take an object, it will be modified. So, and create a new version. So if anything just changes even a fraction, we'll create a new version. So why is this such a big deal? Well, let's say you've got a server and the server's got, 256 cores and 8 terabytes of DRAM. If you're going to use that server with, say, Red Hat or any other operating system, but it's a business, you probably use Red Hat a lot of the time. And you actually look at it. If you've got 8 terabytes of physical DRAM, you're going to have a 12 terabyte swap file. And a swap file is virtual memory. And what happens is if your system runs out of DRAM, it writes to the hard drive. So if you've got a server with a 12 terabyte swap file, and that swap file changes 50,000 times in a minute, you will have 50,000 12 terabyte objects. And you just paid millions of dollars in storage for less than 1 day's work, about an hour's work. So think about that. So object storage, and we'll talk about it, is used for software distribution, backup and archival purposes, and big data because of its metadata. So the other typical type of storage that we have is file storage. So file storage is traditional storage. The hard drive in your computer is traditional storage. It uses a normal file system like NTFS that Windows would use, for example. Can be mounted by any kind of device. Can be over a network, for example, with an NFS file share for, say, a Linux system or a Unix system, or a server message block share on a Windows system. Of course, you could use a Linux system to serve Windows by using Samba, which is basically SMB on Linux, but that's there. And you're going to see it's going to be hierarchical. You may have a folder that says root, and then you've got a folder that says homes. And under homes, you've got one that says mgibbs. So kind of keep that in the back of your mind. So now let's talk about the AWS versions of the storage. Why did I teach you this? Because if you don't know storage, you can't work anywhere. And more importantly, everybody's multi-cloud, 98% of the people. So if you know block storage, object storage, and file storage, it's the same thing on any cloud. It's kind of like getting your eggs at, say, Aldi versus Publix versus Albertsons. Just eggs, just in a different store. Maybe they have different names for it. So let's talk about object storage on AWS. And that is going to be called Amazon Simple Storage, otherwise known as S3. What is it? It's object storage. And it's going to be integrated in many AWS services. It's considered high availability storage. You know, they'll tell you 4 nines availability. That means 99.99% of the time you'll be able to access it. What that means is about 52 minutes of the year you won't be able to. And that's, okay for most purposes. What is really cool about S3 is the durability. And, all the cloud providers have high durability. What is durability versus availability? Availability is having access to it when you need it. Durability is, will I be able to get my data back if anything happens? So let's say the Amazon cloud goes down. When it comes back, you should still have access to all your data. So, they talk about 11 nines durability of the data, and that means that it's 99.999999999. I think that was 9 nines past the decimal point. It's hard to do these live. So, and any kind of notification you'll get on Amazon S3 will be via Eventbridge, which for the most part is the old CloudWatch. So, where would you use S3? Backup and archival for your organization's data. Maybe you're sending your data to the cloud before you put it onto your systems. You've got a static website that's not going to change. It's a beautiful place to put it in an object storage, otherwise known as S3 for AWS. You want to distribute video or media or software. Object storage is the way to go. It's good for disaster recovery planning because you're storing images of, say, virtual servers and things in it. And it's good for big data analytics because of that metadata. So Amazon S3, when you set it up, you organize it into buckets. The buckets are just for us in our head. There's no such thing as folders in object storage, but it's for us. Now, each bucket that we create is basically going to be a container for, say, files that'll be stored as objects on S3. And when we deal with this, the buckets are going to have a top-level domain name space, meaning they must be globally unique and can be accessed by their DNS name. This is another reason for, object storage. It gets a fully qualified domain name. And because of that fully qualified domain name, it's very easy to just use as a website or click this and the person will download it via standard web browser. So when you create your bucket names, they can have up to 63 characters in length, and that could be including letters, numbers, hyphens, and periods. It's noteworthy that the path you use to access the files on S3 isn't necessarily where the files are going to be stored. That old buckets and those little folder things you're creating, those delimiters, that's for us in our minds. It's not related to object storage. Object storage just dumps it into storage and puts a database-like pointer to it. So, and really when we access a URL, our file is really a pointer where the database is actually stored. So you can almost think of object storage as like a huge database. And that's why in certain circumstances, you can run SQL queries on the data in your object storage. So remember, it is not like traditional storage. It's organized like a database. Now, you can create any kind of delimiter you want. And by doing so, it feels normal. So, here's a fake folder that I don't have it on S3, but I'll pop it into the chat box so you can see what it looks like. I could create something like this. And that's going to look and feel like a standard Unix directory. And it's in the chat box. I just dropped it in there. But so let's say I made a video s3.mp4, but it's not really there. That's for me to be able to reach it, but it's in that whole dumping ground where they just throw everything there and have a database pointer to it. So we're going to talk a lot more about S3, but at least we introduced block storage, object storage, file storage. We gave you a little info on S3. Let's see if there's any questions. And if there are, we'll answer some questions. And then we'll get back to the fun. I love teaching. So to me, this kind of stuff is fun. Chris, let's see if anyone has any questions. While I wait for Chris to pop them up, I wanted to ask you that if you're having a good time, if you can hit the like button, subscribe to the channel, and hit the bell to be notified of others. Please tell other people about this YouTube channel and this training, because we spend a lot of time, effort, and money putting these together, and we want as many people all over the world to access this free training. And look at the first one. How do you hide master and schema credentials while architect developers are creating an application stack via IAC? So, we're not talking about Terraform today in any way, shape, or form. That would be something else. And Terraform is not an architect thing, but I can give you some basic information. To hide, master and schema credentials while creating an application stack via infrastructure as code with Terraform, you can do the following. Under environmental variables, you can store sensitive information in environmental variables and reference them in your Terraform configuration. There's also the Terraform Vault. And HashiCorp has a vault to securely store and where you can store and access your secrets. You can also store them in the AWS Secrets Manager. And, those are some ways that you could do it. But, make sure you're using IAM roles and policies to grant Terraform its necessary permissions. How to design and play a PC game? Well, that's going to take a collaboration. So first we need to know what the game is. Then we need to know what the goals of the game are. It will take someone like me that's a cloud architect to basically put a team together. And I would bring in some application architects and ask them how they would design the application. I would bring in some good data architects and database architects to try to determine where we need to keep the data, what kinds of databases will scale, and their recommendants for scaling and performing it. Then we're going to bring in a network architect to make sure that we have the networking that has the latency that it needs to be. Beyond that, we might be mining that data, and we want to mine that data to make some business recommendations and new sales to our clients. Plus, we may want to use some machine learning on that. So that means we're going to be bringing in some AI architects, and we'll also be bringing in some data scientists, for example, to come look at this. And then we're going to, obviously get the client's recommendations, the client's goals, get our architects together. And in about 3 to 6 months, you'll have an actual architecture that could make something like that happen. And then it's a matter of setting up the governance structure, setting up the statement of work, determining what type of people you need to have to both deploy these systems and then manage these systems after the fact. Then it's getting the key stakeholders to make sure they're going to support it. Then it's about finding the budget for it, creating the budget, and or bringing in investors as needed. That probably means building a small scale proof of concept and proving that there's something worth. So it's going to be something big like that. So, that's the kind of thing I would teach the students in our Cloud Architect Career Development Program or Enterprise Architect Career Development Program. But you have to understand, not only is that a training program where we take people in and they can stay on the program until they're hired, it's at least 800-900 hours of training. So you're asking a question that would take the next 2 weeks to answer. So I appreciate the question, though. And we could teach you how to do that in our architecture programs. Can 100 EC2 instances be merged into a single instance? Well, yeah, it depends on what they are. So they have like these little micro T instances that have less than one core. And let's say you have them on the AWS. I think they call them I-3 instances. They're the ones they call general purpose compute, and they run the Intel Xeon E5 2670 V3 73 or something like that, V3s. Well, let's say we had 48 instances on that one per virtual core, because those systems, let's say, have 24 physical cores. And then we have another one that's got another 48 virtual machines on it. Heck, let's add another one that's got another 48 virtual machines. We can easily take every single one of those virtual machines and move it to one of the new AMD EPYC servers. And we could probably put, about 300 or 400 little one-core servers on that single virtual machine. But again, we have to analyze the use case. Are we better off with a whole bunch of little mini servers and a load balancer? Is it cheaper for us to use 500 mini servers and load balancers than it is one big server? If we use a single big server versus having 200 of them, now we've created a single point of failure. So what is it we're really doing? So anytime we get into compute, and we're going to talk about compute tomorrow, but anytime we get into compute, we have to determine, is it a single threaded application? Is it a multi-threaded application? Does the application do better with higher frequencies or more cores? And, it's not just the frequency and the clock rate. There are certain applications that do better on different processors. So we really have to take our applications, know what they need to be, and then test their performance on various systems, because everything looks good in marketing documents. I have a firewall that's supposed to do 1 gigabit stateful throughput, and it does. And then I turn on any of the advanced security features, and it goes down to 80 megabits per second of stateful throughput. But the brochure says, gigabit per second. And that's pretty normal. So that's why you're going to have to test any application on multiple processors to determine, and memory types of memory to determine where you're really going to put them long term. But yes, you can do it. What is called invisible storage? So invisible storage is a made-up word. I don't recommend you using it ever. I recommend that using standard terminology, and that's how you avoid errors. And for example, I had a student one day that actually got a job, and he said, "Mike, I got a job. How much money should I ask for?" And I said, "What's it about?" And he said, "VM." And I said, "You mean working on virtual machines? Do you mean working on voicemail systems? Or do you mean vulnerability management?" And he started laughing and saying it was vulnerability management. So if you use standard terms. So what is invisible storage? It's basically ephemeral storage, meaning storage that goes away, or the storage that's sitting on your virtual machine itself. But once you get into jargon and you get into slang, you really can confuse a whole lot of people. So I just recommend calling it either instant storage or ephemeral storage, which are the two industry standard terms, and you'll be in good shape. What types of data storage are there for the 3 storage type? We have object storage, which if you're on AWS will be called S3. If you're on Microsoft, it'll be called Blob. And if you're on Google, it'll be called cloud storage. The next type of storage we have is block storage. So AWS calls it elastic block storage because they like to stick with the word elastic in front of everything. Azure calls it, say, a managed disk. And file storage, which we'll get into soon, is really for basically where you store things on a hard drive or a folder. So what do you store on what? Well, on a server, let's say you're going to run on a physical server itself, or you actually got a bare metal server and you wanted to run everything on the bare metal, most likely you're going to run the hypervisor on file storage because that's what's going to be in your server. If you wanted to have a high performance Linux system, and for example, and you had a super low latency application for a bank where a nanosecond of latency could equal $50 million a year, so you're trying to scrape those nanoseconds together, you wouldn't use a virtualized environment. You'd put your operating system directly on the hardware because that can give you about a 5 to 10% boost. So in that situation, you could be storing your databases directly on the file server. So anytime you want to store directly in the server with file storage, you can store anything. Now, block storage. What is block storage? Block storage is network attached storage, which we're going to talk a lot more about. But it looks and feels like file storage to a server. It's not. It's a virtual hard drive that's sitting, someplace else. But to the server, it feels like file storage. So you can use that. You can put anything on block storage. Now, I want you to remember this. Block storage is going to be slow. And they'll talk about it being fast, but it's relatively slow compared to other storage options. But it's not in the system. So the system thinks it's a hard drive. So where do you use block storage in the cloud? You use it anytime you want information on a virtual machine that isn't going to go away when you delete the system. So If you have a database, you will use block storage. If you have a web server, you'll use block storage. If you have an HR application, it'll be sitting on a virtual machine running block storage. So block storage is for is a virtual hard drive, so you'll mount it to your virtual machines. You can mount it to your containers as well. Now, when we get into file storage, I initially talked about the file storage that's inside of your system, but file storage could also be over a network. So if you had 50 servers that wanted to access the same information at the same time, that'll be file storage. If they're Linux systems, it'll be NFS, or the AWS branded version of NFS, which is EFS. Now, object storage, that's the last type of storage. What do we put there? I want to back up my data, I stick it on object storage. I want to create an image of my virtual machines, I stick it on object storage. I make a video of Cindy the cat, I store it on object storage, and I send the link to that video of Cindy the cat to all my friends. Object storage, like Google Drive, which you may use, or Microsoft, what do they call that? The drive that comes with Office, that type of a drive as well. That's all kind of object storage. So you might also put a static website on object storage. So I think I give you a little more than you asked for, but I wanted to make sure you got it. Can data be both block and object storage? You can store your data on block storage, object storage, and file storage. Basically, your block storage would be what your hard drive would use. You might put it in file storage and share it with many other systems at the same time. And object storage is where you'd back it up. But you got to remember, the servers are not going to use object storage. They're going to use block storage. Where servers are going to use file storage that are sitting inside them. But now you can have all three up in the same time, but with different purposes and different applications. It's not going to be attached to the system. Difference between S3 and EBS and RDS. Okay, S3, object storage. EBS, block storage. RDS is a database, a relational database system. So don't mix the two together. In one case, you've got storage, and in another case, you've got applications. We'll cover databases and database management systems like RDS when we cover the database information. And we actually haven't covered EBS yet either. But we will. Okay, so actually, before we begin, give me a hashtag, AWS Solution Architect Associate. Give me a hashtag that, and that way I know you're awake, and I will get back to teaching. Have to make sure you're not sleeping. Okay, so now let's talk about some S3 storage tiers. When you store your information on S3, there's a couple ways you can actually do it. So object storage is object storage, but AWS can market object storage in multiple different ways, and they can give you different levels of access to your information. So that's really what storage classes are. You'll have the opportunity to have reduced availability of your storage if you wanted that for cheaper prices. You'll have the ability to store it in a location where it might take you half a day to get access to the information if you wanted to get a cheaper price, or you'll be able to store it where you can get access to it anytime you feel like it. So when do you choose which? When you understand your organization's data patterns, capacity planning, understanding your systems is truly, truly critical. So, and it's OneDrive. That's right, Brian. Thank you for object storage on with the Windows system. So let's talk about standard S3. Standard S3 is going to be Amazon's high availability performance, meaning 99.99% available, meaning it should be up except for 50 minutes of downtime per year. High durability, meaning your data shouldn't get lost. We'll call it high performance. We'll call it high performance, although no cloud storage is high performance for the most part, except for Lustre. And it's going to be used for standard for frequently accessed data, meaning you're going to use your data, you're going to pull it back. And why is that? It's designed for data that you're going to use frequently. So let's say you're a magazine and you've published an article, right? And an article is stored on object storage for some reason because it's like lots of graphics on it. For a period of 30 days, everybody's going to look at that video, for example, right? And the article, and they're going to read it a lot. So you want it in an area where you can get it anytime you want. But maybe 90 days later, nobody accesses that data, or when they access it, it's occasionally. So you want to pay less to store your data and pay each time they access. And then maybe there's a point where that data is never going to be seen, but we have to archive it for legal purposes. So we'll stick it in some cheap archive, and if we need it, we'll pay to get it. So understand that's why they have these storage tiers. So we first talked about the normal storage tier. You store it, you pay one price, and you can access it anytime you want. The next phase down is going to be something called Amazon S3 infrequent access. It's got good availability, same as S3, the standard, just as durable. Your data won't be lost. Performance will be the same, and you get a cheaper price to store your data. But when you want your data, you have to pay to receive it. It's instantly available, but you have to pay. So we started at the top, standard with the highest pay, but you can access it anytime you want without no cost. This was infrequent access, where you pay less to store it, but you pay to retrieve your data. So you're going to use that in a pattern where you don't need your data as often. Now, the next type of storage that's going to be a little cheaper, and this is going to be Amazon S3 infrequent access one zone. So what's that? It's infrequent access, meaning you're going to pay for retrieval. You're going to get a lower price to put it there. But it's going to be in one data center versus two data centers. And because of that, your data is less likely to be available when you need it. It'll have reduced availability. So if you might not need access immediately to your data, and you're looking for a cheaper price, with this S3 infrequent access option, both you get a really cheap price to store your data, you get a reduced price because it's not always as available, and then you pay to retrieve your data. So again, you don't use this with data that you need a lot. And the next is going to be S3 intelligent tiering. And this is where AWS is going to monitor your data, and they're going to try to auto move you to what it thinks is the most cost optimized platform. But you're asking somebody else to put you in the lowest cost pricing. Not sure that that's necessarily the best way to do it. You really want to plan your finances and manage yourself. To VJ, who just asked the question, you need to know these? Yes. There's almost no architecture on the Solution Architect Associate certification, but there's a lot of product questions on, what's this versus what's this versus this. So we're going into that product detail here. And then otherwise, we're going to actually talk about technology as well. So we've covered the three forms of infrequent access and the automatic version for you. The next type of S3 is something called Amazon S3 Glacier Flexible. And this is, and basically this is designed for data archival purposes. You can get something called the vault lock to make it immutable. And what's immutable mean? It means it can't be changed. So you're a bank or a hospital, and you have to store your records for 7 years, and no one can change these records for some years. You can store it on Amazon S3 Glacier and set up the immutable, and then no one can change it. So when the government or the Joint Commission on Healthcare tries to investigate you, or the SEC when they do their normal audits of hospitals, or SEC does audits of businesses periodically, or those kinds of things, you can just hand them your data. So can you keep that in the back of your mind? Hospitals get audited all the time by a Joint Commission of Hospital Accreditors to make sure that hospitals keep their accreditation. So they need these kind of forms. So with Glacier Flexible, which is the old traditional Glacier, It's designed to make sense financially if you're going to access some of your data 1 to 2 times per year. Your data can be retrieved in minutes to hours when needed. So with S3, you can get it anytime you want and you don't need to pay for it. Here, you can get it in minutes to hours. So it's not going to be instantly there. So if you need it for business purposes, it's critical. No, you don't have to worry about it. So there is another form of S3, and it's called S3 Glacier Instant Retrieval. And this is going to be for low-cost long-term storage. So it's instant retrievable, meaning you can get it when you want it instantly, just like you could with standard S3. And the access cost at the time that we made these slides was 68% lower, according to AWS, than S3 and frequent access. But, there's a retrieval fee. So there is that option. And then here's the lowest cost storage on AWS, and it's S3 Glacier Deep Archive. So relatively low cost storage. It's optimized for archiving data that can be received in, say, 12 to 24 hours. It's designed for information that's not accessed more than annually. And the data is stored in 3 data centers, and it's for long-term storage, like for regulated industries. So there are your S3 options. And, cost management of these things is important because in the cloud, it's very expensive to store data. The example is, I'll give you an example. In my personal data center, I have a 93 terabyte RAID array that I use for our videos. It was about $5,000 to set that up. On the cloud, it's almost that price every single month. It's like $3,000 to $4,000 on a cloud provider to store it every month. So if you bought 2 of them and had 1 in 2 different data centers, it's $10,000 for a RAID array that an organization can purchase. Or on the cloud, say $36,000 a year. For 3 years is $100,000 versus $10,000 to buy it. So this is where we have to be really smart about where we start our data, and that's why we're talking about these options. So now that we understand these options, you got your standard S3 for stuff you're going to access all the time, and an S3 infrequent access for things that you might use periodically. And we've got this Glacier stuff that's cheap. How do we put the pieces together? So this is where we deal with something that you would consider a storage lifecycle policy. And what does that mean? It means that you put it in an environment and set up a policy. So let's say you're going to need your data all the time for 30 days. You put it in Amazon S3. 30 days later, you're going to need it periodically, and you're looking to cut your storage costs down. No big deal. Put it in S3 and frequent access. I don't think I'm going to need that data for a year, and if I only do, I'm only going to need a little of it. Stick it in Glacier and cut your storage costs. So that's going to be called a lifecycle management policy. You obviously can do this on all cloud providers, and you will in an architecture we're trying to optimize cost. And it's configured when the people set it up. So Amazon has something they like to call versioning. So with object storage, anytime an object's modified or in any way, it creates a new version. That's standard object storage. You go buy it from any object storage vendor, that's what you're going to get. But most people aren't very familiar with object storage. And they wouldn't be thrilled with the idea that if they were writing a Microsoft Word document, it was stored on object storage, and they saved it every 10 minutes, that every 10 minutes they'd get a new version of it. And in the cloud, when you pay for storage, you might not want to pay for 10 darn versions of the single thing because you changed it 10 times inside of 30 minutes. So they automatically delete, or at least to use, the multiple versions that are there, unless you want to use it. So if you want to use S3 versioning, they bring you back to normal object storage, where anytime something's touched or modified even a little bit, it creates a new version. So if I were to write a document and store it in an object storage, let's say I called it CSA.docx, Certified Solutions Architect, and I saved it the first time, the second time I had version 2, third time I had version 3. And, it may make sense sometimes to store 154 versions of your document. Why? You corrupt the version number 154, you go back to version 153, and you're good to go. And there's times that you might want to do versioning. So Amazon enables you to label versioning to work as it was by default with object storage. So there you go. It's an option. What they call it, a feature. So With S3, we have the opportunity to do something called multi-factor authentication delete. So what's this mean? In business, you don't want a user to really delete your key stuff, right? And it happens all the time. So I've got a user that wants to delete something. So with multi-factor authentication delete, they go to delete the photo, cindythecat.jpg. And then the customer is sent a multi-factor authentication challenge. And it could be like a text message, or it could be the kind of thing that you're looking for where you've got like a Google Authenticator or a hardware token card. And then you give them that one-time password, and then the object is deleted. And that prevents a hacker, for example, that gets access to your username and password from breaking into your system and deleting your critical data. So setting up multi-factor authentication delete is pretty important. So how do we secure our information on S3? You, realistically speaking, have two options. The main option you can do is something called a bucket policy. And this is going to be your preferred method, and it's going to be fairly granular. And it's going to be based on identity and access management lists, outage management, and not a network-based access list that you would see on, say, a router or a network ACL in AWS, but an access control list that you would have in, say, terms of permissions like Unix permissions. And it's going to be a JSON script that'll have a policy that'll determine what people can or can't do. Now, let's talk about encryption. If you're going to store your information, it should be encrypted so nobody else can get access to it. So anything sensitive, you should actually encrypt and keep that in the back of your mind. So with AWS, they now traditionally encrypt your data for you, but they didn't until recently. But when it comes to encryption, we have a couple ways we can do it. So we're going to talk about the encryption options. What is encryption? Encryption is if I take one thing and I turn it into something that's an undecipherable text unless you've got a secret decoder ring. So there's lots of types of encryption that are used. Encryption is used in military communications. Encryption is used on your iPhone. But encryption's been around for a long period of time. Quite frankly, if I spoke to somebody in English and then translated it in Greek and there were no other Greek speakers in the room, that would be encryption. if there was, because nobody else would be able to decipher it. Now, if I brought in a Greek translator and I had somebody speaking to me in English and I spoke to somebody in Greek, but there was a Greek translator telling everybody else what I meant in English, that would obviously not be good encryption. Well, basically, we encrypt with a secret key, and then the user has the same secret key and they know how to decrypt it. So that's what encryption is for the most part. We'll talk more about encryption in other places. But realistically speaking, we can encrypt the data on the client side and we can encrypt the data on the server side. So we have that option where we're going to store it. So we have options with regards to the key management systems. We're going to have the SSE-KMS. And this option is going to be a complete key management solution. The user will manage the master key, and the key management system will manage the data key, and the key management system will provide an audit trail of who and how and when the data was accessed. So that's not the slide I was looking for. So, and how your data was accessed. So realistically speaking, in this environment, you've got your master key, and then there's the data key that's used to decrypt and encrypt the data. But you manage the master key and everything else is done for you. Now, the next option is give more of this key management stuff to AWS. And in a high security environment, you're going to give less of your key stuff to the external provider. But in a lower security environment, you may look for somebody to actually manage everything for you. So the next thing that we have is SSE-S3. And this is going to be an AWS complete key management solution. Amazon's key management solution will manage all the keys. It'll automatically rotate your keys. So in case a key gets compromised, it won't stick around too long. And every object will be encrypted with its own encryption key. It's a great automated system, but generally speaking, in high security environments, you don't want anybody to manage your keys for you. So in this particular case, especially the master key, the SSE-S3, AWS is going to manage the master key, the data key. So much, much, much easier. And then next we will get to SSE-C. And this is an environment where you've got complete autonomy over your encryption keys. The customer manages all the keys. So this is what you're going to see in a high security environment. You're not going to be giving your key management system away to anybody else. So in this particular case, customer manages everything and provides everything and secures their data. Think high security environments, we're going to have that. So let's talk about some things. Yeah, I'll go for a few more. Let's talk about some more things for S3. We can tune S3 to improve our performance. One of the things that we can do is pre-signed URLs, and we'll talk about that. We will talk about multi-part uploads. We will talk about range gets, and then we will talk about cross-region replication. And then I will open it up for questions. And while most of the questions that we're going to take today are going to be related to this content, Alam actually asked a very dangerous question, and I want to answer his question at the next break, because that's the difference. What he needs to know here is super important, and I think other people may need to know it as well. So I want to make sure I get to that fairly quickly. So let's talk first about these optimizations. So the first optimization is something called a pre-signed URL. So when you put an object or something into an object storage environment or AWS S3, you're going to need to enable private access. You're going to need to enable access to the object. And do you want to allow other people access into your object storage and have a whole bunch of permissions and usernames and passwords out there? Or can you just pre-sign the file that you want to give them, and you sign it with your encryption key, and you give temporary access for maybe 24 hours or something for the person to get their file, and they no longer have access again? So pre-signed URLs are going to be used all the time. And when you sign a pre-signed URL, the way you sign it will determine the expiration. And certain types of expirations, certain types of signing things are going to be potentially, more secure. So they'll give you different times. So these are the types of ways you can sign a pre-signed URL when you send it to someone to retrieve something via object storage. You can sign it with your IAM instance profile, and that's good for 6 hours. You can sign it with the token security token service, which we'll talk about later when we talk about the security section, which is good for 36 hours. You can sign it as an IAM user, and that's going to be good for, say, 7 days. You can give a temporary token, and that's until it expires. So it's a pre-signed URL. The next thing I want to talk about is a multi-part upload. So let's talk about things over a network. When you send data over the network, it doesn't always get there. Sometimes the network has an error and the connection is lost. So when you're sending a lot of data, the problem becomes worse. So imagine you upload 4 terabytes of a file, and then the internet connection or the session gets torn down because of a little congestion at one point on the internet for, say, 30 seconds. And now you've got to resend that whole 5 terabyte file. And the next time you send it, it gets cut off at 3.5 terabytes. And you got to go resend it again. So when you're transferring large files over the internet, where internet performance isn't guaranteed, there's so many things that can go wrong. Now, if I'm sending a standard photo of my cat Cindy, and it's a 50 meg file, that's not going to be a big deal. It's going to get there. But, if we were to take a 400 megapixel photo of my cat Cindy, and now it's a 5 terabyte file, because it was in some kind of crazy resolution and crazy things were added to it, that's going to be hard to move. So you have an option of either try to send it all at once, and if any part of it doesn't get there, you got to send it all over again. Or take what you have and divide it into smaller pieces. Piece 1, piece 2, piece 3, piece 4, piece 5, what have you. Piece 1 gets there. Okay, then you send piece 2. and then you send piece 3, and then you send piece 4, and you send piece 5. Or you can send all 5 pieces at the same time, and if any one of them gets lost, say piece 4, you just resend piece 4. So that's going to be a multi-part upload, and that's going to be a recommendation from Amazon. What's it going to look like? It's going to look like something like this. You got a big video, and you chop it into small parts. With S3 will do this for you, and then you push it, gets put together back when you store it. So this is going to give you a lot of control, and it's going to improve the transmissions of your files across the internet. So last piece we'll talk about is something called cross-region replication. So what's this? Let's say we are in, say, North America, right? We've got our data in North America, and we want to replicate it to a bucket into a place in Japan. And every time I store something with data in one site, I want it to move to another site. Exactly, that's going to be cross-region replication. Imagine we have an object storage-based website. I update parts of the website in the US, and instantly the Japanese website's updated. So by doing so, if the data is in Japan, we're going to pay less cross-regional transfer charges, which we'll get to at some point. But here's the thing with Amazon or any cloud provider. Anytime you have to go across areas or regions, you've got to pay extra transfer fees to use the system. So sometimes it's cheaper to store your data in 2 places and let people in 2 places access their data more locally. That could be another reason why we use cross-region replication. And here's an example of that. Okay, Chris, I'll take a few minutes of questions right now, and then we'll get back to the content, and we'll go. And we get back to it, we'll get to instant storage. How to choose labs for solution architect because you're confused. There may be many labs which are related to DevOps. Well, I'm so glad you asked this question. Do you want to know what a cloud architect or a solution architect does? We do the following steps. We go to our client and we ask our client about their business goals, their business pain points, their business challenge, where they see the business wanting to be now, 5 years from now, 10 years from now, and 20 years from now. When we understand the organization's vision, the next thing we do is going to be as follows. We're going to learn the organization's business processes, especially if we're doing our job right. How does the organization operate? How are products made? How are services delivered? What have you? How is the customer supported? And then we ask that client, is this the way you want the business to work in the future? And they say, no, we want to change these parts of the business. That's why we brought you here. So then you work with the client to determine the ideal way something could be. I think yesterday or the last time I asked this, let's say you have a retail store, like an online retailer like Amazon. And they determine that to increase sales, they want to create a recommendation engine that's going to look at all the things you've purchased in the past and your hobbies and your Facebook and your Google and whatever you have out there and make customized recommendations for you. And I'm sure Amazon has their own recommendation system. And I'm also not going to say they're going through your social media, but theoretically that was the case. So that's the new way we want the customer to experience the system. The next thing we do as solutions architects or cloud architects or enterprise architects or AI architects is we go to that organization and we bring in a team of, say, engineers. They're going to help baseline that systems and evaluate the tech and its performance levels like CPU utilization, memory utilization, disk storage, security vulnerabilities that they find. Then after that, as an architect, I'm going to now build a team of an architecture team. And I'm going to create a team and say, okay, to get the customer to do this, we're going to need to improve their data environment because their data sources aren't good. They need some data hygiene practices. We've got to clean up the data. So I bring in a data scientist and I bring in a big data architect. I then say we're going to need low-level network really good network performance with low latency. So I bring in a network architect. The next thing I realize is, we also need to optimize the communications between point A and point B, and I bring in a unified communications architect. I bring in a security architect to make sure the systems are there. Together, I lead that architecture team along, and I lead that architecture team into a solution. I then lead that architecture team into documenting the solution. The next thing that I do at Alam is I go socialize that solution or talk about that solution with key stakeholders in various business units and get their feedback. After their feedback, I tune the architecture, and then I get together with the account team and we present that architecture to the client and sell that architecture to the client, and we negotiate the deal with the client. Then we write up a state. We have make sure we should have written up a statement of work, determine what type of resources are necessary for the project, and as soon as we're done that, we leave. So, as solutions architects, we don't ever touch the technology. We don't code, we don't configure, we don't do Terraform, we don't do sysops, we don't do DevOps. So a solution architect lab would be to create a technology blueprint to help a bank, improve some new service, or help an airline manage fuel costs by leveraging artificial intelligence to make fuel price predictions based upon news cycles so they can purchase options at another time. So, these are going to be there. And, it's not related to the certification. This is the job. And that's why, and I wasn't going to talk about it, but that's why we have our Cloud Architect Career Development Program to take people that are either certified or not certified and train them to be architects. So these aren't labs you're going to find out there on the internet. These are labs that you would get in either an MBA program. These are labs that you would get in our Cloud Architect Career Development Program. These are labs that if you were taught by David Lithicum and he teaches our AI architect program, he would do. This is architecture. So this certification is going to be a good certification because it's going to teach you the AWS services. We're also going way beyond that to teach you some of those network and a data center things. And this certification will help you get an interview. Just make sure you actually learn what an architect is and what an architect does and get the skills that you need to do what I told you. Because they're not going to be hands-on labs. You just can't learn how to design for a business that way. If Amazon EFS is used on premises, can S3 be used on premises? So here's the thing. EFS, and we're going to talk about EFS, is network storage. Network storage. It's network file storage. So in your data center, you could pay AWS for EFS and then bring it over your wide area network to your VPC, or you could just use file storage in your data center and pay much less for it. So when you go to EFS, it's managed for you. So you pay a lot more for it for lack of complexity. But if you're going to use it on premise and you have your file storage on premise, you don't have the latency of the cloud, which is going to be poor performance compared to what you could do locally. And it's going to cost a whole lot less for better performance to do it locally. So you wouldn't use EFS on premise. Now, realistically speaking, and if an organization needs good object storage performance, they're not going to use S3 either. They're going to buy object storage from Dell EMC and have it in their data center. Now, if they wanted to, if the organization has a good direct connection to the cloud, they can use information that's stored on S3 back in their data center. In a hybrid cloud, we would do this kind of stuff all the time. And they can even use, and we'll talk about storage gateways and how to do that as well. But if you've got the option to be in your data center, why would you choose a solution that's 1,000 miles away that's going to perform half of what you can do for double the cost? But it can be done. So in order to make it work, you're going to have to use a storage gateway for S3. What is the likely role of a security architect? A security architect will do everything that I just told you as an architect, but what they will be doing is designing the security solutions. And I've trained lots of security architects as well. So they will be going to the organization and they will be evaluating the assets that they have. What are their assets in terms of physical assets, intellectual property, data, whatever it is. They will quantify that. They will then determine the next option will be they will determine the organization's threats. Then they will evaluate the organization's vulnerabilities. Then a security act would evaluate the organization's people and test those people and kind of see would they fall into social engineering scams. The security architect may also bring in a penetration tester to try and hack into the systems to find the weaknesses in the system. The security architect would work with that client to figure out what their data needs are and work with them to prevent a data loss prevention strategy. The security architect would work to find the security policy of the organization and at a high level what needs to be done, what needs to be done on the physical security side, what needs to be done on the policy side, what needs to happen in an incident, for example, who were the incident management team, who communicates during an incident, which legal teams are involved, etc. The security architect might be working with lawyers to determine governance, risk, and compliance to make sure that the organization is there. The security architect would be designing the end-to-end encryption strategy, for example. The security architect would work with an identity and access management strategy to really determine that organization's identity and access management. And then, of course, the security architect, like any architect, will be delivering presentations, selling things, selling the vision, determining the people on the price. So just like the cloud architect, but they're focused on security, where the cloud architect is focused on everything. And that's why they've got to bring in all these extra architects, like security architects, to support them. Good question. All right. Well, let's get back into the content. The reason I wanted to get that, and I'm pretty passionate about it, is, I've trained cloud engineers and made them cloud architects, and I've trained, nurses, mental health techs, and teachers, and it takes about the same time to train both of them, because architecture is about system design to optimize business performance, and engineering is about building systems. So kind of keep that in the back of your mind. Okay, so let me know that you're awake, alert, and oriented by giving me a hashtag AWS. And now I'm going to talk about instance storage. So I'm going to talk about it very briefly, and then I'll get into elastic block storage. Instance storage is the storage that's sitting inside the server. And this is blazingly fast. Blazingly fast. And the problem with instance storage is that it's ephemeral, meaning that it actually gets deleted when you terminate your EC2 instance. So that's what that invisible storage was that person was asking about. Here's what it's going to kind of look like. It's in the virtual machine itself, but it's deleted when you terminate it. So if we're now talking about block storage, we already talked about object storage and what it's used for. Let's talk about block storage. Because you can't go into the servers and the cloud providers and stick your own hard drives in, and because anything that's on instance storage or ephemeral storage in the server gets deleted, the only thing that you can really work with is block storage for your virtual machines. Have a database, its hard drive is going to be block storage. Have a web server, its hard drive is going to be block storage. So kind of hope that makes sense. Now, block storage is the fastest storage we're going to get on the cloud. Is it fast? No. But it is the fastest we're going to get on the cloud. There are times that organizations will not be able to deal with the performance issues of block storage because it's so slow, even if they call it fast. I'll give you an example. The fastest IOPS, and we'll get to that, we can get in block storage with AWS, and that's pretty fast for block storage, is 250,000 IOPS. I can buy a RAID card for my server and get 19 million IOPS for a server sitting on my desk if I wanted to. So big difference between the high performance storage and you can get in the data center versus block storage. But on the cloud, this is the fastest we get. So we got to fall in love with it, or at least use it because it's our only option. And we often use these in private clouds too because of their scalability. So because the files are written in blocks, in much like file storage is, when we deal with block storage, it's going to feel like a virtual hard drive to the computer. It scales incredibly well. Because if we need block storage, though, all the cloud provider does is they buy another RAID array filled with hard drives, plug it into their network, and it is up and running. So it makes it very easy for them to create this dynamically huge storage pool. It is highly reliable. And it's because it's block storage has been around for a couple of decades. It's tried and true. And, they'll say that their storage is available 99.999% of the time, which means up except for 5 minutes downtime per year. Now, because it's the fastest we can use, except for Lustre, which we'll talk about, it's going to be optimal for high throughput, high transaction workloads. And because we have to pay for it, the cloud providers will give you multiple performance options, from really horrible performance to good enough performance. And good enough performance gets real expensive real fast. So because block storage is network attached storage and it's got to be somewhat high speed and low latency, it's typically inside of the data center and not over a wide area network. So, for example, it's associated with a single availability zone, but it's going to be backed up to another availability zone. And when you're dealing with block storage, you can back it up into a snapshot. And what is a snapshot? It is a bit by bit identical copy of the system. And when we get to databases, we'll talk about going from snapshots to a live system. But it'll be backed up as in a snapshot. And where do you think these snapshots are backed up in archival? Where do we put backup on archivals in the cloud? We put it in object storage. So their block storage volumes or elastic block storage volumes will be backed up into S3. So let's talk about choosing the right type of block storage volume, elastic block storage volume, EBS volume, whatever you want to call it. What do we have to think about with storage? We have to think about performance. Now, when it comes to storage, we're going to have two things to think about: latency and throughput. So latency is how long it takes for something like basically start or finish, that kind of thing, to go from point A to point B. Throughput is how much stuff you are going to move. So I got two cars side by side. Card one is a Ferrari and it's fully maxed out, and I want to go drive a quarter of a mile on it. The Ferrari is in my left hand. In my right hand, I got a tractor trailer. So these two are on a track and they do a race for a quarter mile. Who do you think gets there first, the Ferrari or the tractor trailer? Well, the Ferrari goes straight off the line, zoom, and it's there. The tractor trailer starts, and it finally gets there. So latency-wise, the Ferrari has less latency than the tractor trailer. Now, throughput is how much stuff it can move. So kind of like torque. So when we talk about storage and we talk about throughput, it's how much stuff we can use. So in that Ferrari, how big's the trunk or the boot or whatever you want to call it in your country? Not that big. Now in the tractor trailer, I can take 60,000 pounds of stuff with me or something like that. So let's talk about the throughput of these two devices. I got to go from Palm Beach to New York City and move a load. Do you take the Ferrari? Do you take the tractor trailer? Well, with the Ferrari, you may have to go back and forth, 50 times. With the tractor trailer, you go once. So that's the throughput. So we're going to measure latency in input and output operations per second. So they will call it IOPS. And what is it? It's how many times you can read and write to the disk in a second. The more times you can read and write, the less latency. Now, throughput is going to be the amount of data that's being moved. So that's typically measured in megabits per second. So we'll talk about the fastest you can possibly get on the cloud. And that is EBS provision IOPS. It's called IO2. IO2 is a form of EBS provision IOPS. It is the fastest. That could likely be a test question. Now, this is the highest performance you're going to get with AWS. It's the lowest latency you're going to get with AWS. It's good for workloads that require high input and output operations per second, like a database. It's good for applications that are low latency. Here's the performance we're going to get. 4,000 megabit per second. Not bad. The NVMe drive in your PC is probably 7,000 megabit per second and just a PC, but this is the fastest we're going to get. Input and output operations per second is maxed out at 250,000. Probably less than the NVMe drive in your PC, but that's the fastest we're going to get. And on the cloud, potentially this might be the fastest of all the cloud providers because it's relatively good. EBS provision IO2. So keep that in the back of your mind. The next speed down is EBS provision IOPS, IO1. So the 250,000 IOPS was IO2. EBS provision IOPS, IO1 is 64,000 IOPS. So they still call this high performance SSD storage. It's relatively low latency. It's still good for workloads that require some medium to high input and output operations per second, like a database. It's good for applications requiring low latency, but 1,000 megabit per second and 64,000 input and output operations per second. So it's not real fast compared to a hard drive that I can get in a server in a data center with 19 million IOPS, but it's still relatively good for normal workloads and some databases. So the next level of storage performance down is going to be EBS general purpose SSD, and it's called GP2. And this is standard SSD drives as opposed to the more modern and high performance NVMe drives that are plugged into a PCIe interface in a server. So these give you a decent value in terms of price performance. It's great for a boot VM where you're going to just boot the operating system because it'll stay after a reboot, and then maybe use an IO2 for where your database is stored, because it's going to give you some decent IOPS, or input and output operations per second, but it's going to be less than the PIOPS, which is already low. It's going to give you some moderate throughput at about 250 megabit a second. And it's good for a transactional workload. It's great for a development and a testing environment because it's relatively inexpensive. And, it's in that environment. If the performance is a little less, you might actually be fine. So the next one we're going to talk about is something called EBS Throughput Optimized Hard Drive, and that is ST1. ST1. And this is magnetic storage, old-fashioned hard drives that spin around. And it's going to be, anytime you're dealing with magnetic drives, input and output operations per second are going to be very low. But because these magnetic drives are in actual, they're in a RAID array, you get about 500 megabit a second. And for a lot of stuff, that's a good throughput, actually. Better than the basic SSD storage they're giving you, double. So it's pretty good for throughput intensive workloads, like pushing video files around. This would be a great place to store it, but not if you need low latency. Huge log files, perfect for this. Anytime you've got sequential read and writes. And the last form that we're going to talk about block storage wise is EBS cold hard drive, and that is SC1. Cold is SC1, and that's going to be your lowest cost. It's magnetic, so it's going to be very high latency, low IOPS, and the throughput's going to be 250 megabit per second. So relatively slow. You don't want to use this unless it's for things that you don't need to access frequently. Okay, so now we're going to get into something pretty important. And this is more of a certified solution architect professional content that we're going to talk about now. Actually, a lot of what we are is, but I want to give you more. So I mentioned that the storage performance on the cloud isn't very good. So how do you make not very good better? Well, this brings us into RAID, or redundant array of inexpensive disks. And we'll talk about what that is. So where did RAID come from? Well, it actually started a long time ago. Here's the thing. Small hard drives, like a terabyte or 4 terabytes anymore are considered small. They're real cheap. But you buy a 20 terabyte drive and it gets real expensive. And you know what? You could generally buy 2 10 terabyte hard drives for a lot less than a 20 terabyte drive. And you can definitely buy 3 10 terabyte hard drives for a lot less than a 30 terabyte hard drive. So what we did many years ago is we combined multiple hard drives together to give us better speed, redundancy, and better performance. I want you to answer this question because you were already part of the yesterday. Did we talk about anything yesterday that can enable an organization to improve their performance by sharing the load across multiple devices? And that way you've got better speed and better performance. Did we talk about anything like that? It also enhanced availability. Pop it into the chat box. Pop it into the chat box. That way I know you were listening, because we talked about a high availability device yesterday. Spread your load across a bunch of servers. While you do that, I'll find some water. Tell me, I'm waiting to see you guys answer this. George, exactly. We talked about a load balancer. Good job, VJ. We talked about load balancers where we had this device that shared the load amongst multiple servers. And if we had 4 servers that each had 4 cores, together we had 16 cores, right? Okay, so RAID is nothing different than load balancing across multiple hard drives. So good, you're paying attention. So now that we get that, and I'm glad you're seeing this, let's talk about RAID. RAID aims to take multiple inexpensive devices, pop them together to get better speed and better performance. And you'll see this everywhere. Every data center uses RAID. I use RAID for our video storage because good performance, lower cost. So RAID volumes will make multiple hard drives look like a single drive. The same way a load balancer could make 10 web servers look like a single web server to the outside world, where you get one IP address which DNS points to. So there's RAID 0, there's RAID 1, there's RAID 5, there's RAID 10, and everything after that, like RAID 50, RAID 60, they're kind of variations of this, except for RAID 4, which actually was designed for SSD drives. And I see we have Mark Trimble in the audience, and he's an expert on this kind of stuff, along with many, many other things. Somebody is really great out there with a lot of knowledge. So let's talk about RAID 0. RAID 0 is basically put a couple of hard drives together and just put data, write half of your data on 50% of the drives, exactly like a load balancer. But data is a little different than the servers in the load balancer. If I put 50% of my data on hard drive 1 and the other 50% of my data on hard drive 2, and I lose hard drive 2, I don't have anything left. I got nothing. Deep with the Zaba, as we would say in Greece. Nothing. So with RAID 0, we pop a couple of hard drives together, we get real fast performance. We get maximum capacity. But if we lose any of the hard drives in the RAID 0 array, we got nothing. So if we need ultra fast speed, we'll use RAID 0. But if we do, back up, and back up some more. So here's what RAID 0 kind of looks like. So pretend where it says RAID 0, pretend that is a RAID card, which is a hardware device like a load balancer that shares load across multiple hard drives. And actually, hopefully you're getting from this that the same technology keeps getting reused. They just changed the name of it. So, and that's going to help you stay focused long term. If your fundamentals are good, you'll always know where the new technology is, because it's going to be something else you worked with in the past. So with RAID 0, you can say, we store our data in blocks, right? So instantly the block goes to the first hard drive, then it goes to the second hard drive, then it goes to the first hard drive, the second, the first. And that way we're writing or striping our data onto 2 drives. Maximum performance here. Best you're ever going to get. But lose either one of these hard drives and you got nothing. So it's less bad in a cloud computing environment. Here's the reason. These things auto back up themselves. And if it's backed up to another availability zone, if you lose anything, you can recover your data a little quicker. But still, RAID 0 is generally considered too dangerous for business. So now, RAID 1. In RAID 0, we put our data on both. And I said that caused, no redundancy. So the exact opposite of RAID 0 is RAID 1. Basically, anything we put on one hard drive instantly copied to the other hard drive. First hard drive or EBS volume goes away. No big deal. I break the mirror and I just tell it to use the second one. So that's going to be maximum availability. But I've now got to write my data on one and the second one. I'm not writing my data on 2 drives, so I didn't get any speed benefit. If I have one hard drive, I've got to back it up as 1. If I have 10, I need another 10. So I think you can see RAID 1 gets real expensive, and it doesn't give you any enhanced capacity, but it gives you a lot of availability. So if your application demands mission critical availability, some flavor of RAID 1 is awesome. If your application needs maximum performance, you're going to need some form of RAID 0, which we'll talk about soon. So We'll get to there. Now, what is RAID 1? It looks just like this. You see a mirror image on each hard drive of all the blocks that are being stored. That's why RAID 1 is called mirroring. So the next type of RAID I'm going to talk about is going to be RAID 5. So if you're a cloud architect like me and you're designing an OpenStack cloud or a Nutanix cloud or even a VMware cloud, and Mark's in there, Mark's got lots of VMware experience, they're going to be using some flavor of RAID 5 in the data center. So you need to know what RAID 5 is, but you won't be able to do RAID 5 on the cloud. And here's the reason why. Remember how we talked about block storage being slow by comparing to, say, those RAID cards you can stick in a server? Well, because of that, anytime you add any kind of redundancy in your RAID, it's going to add a little latency. And we can't slow down the already slow cloud EBS volume. So RAID 5 is not going to be allowed in the cloud, but you might need it in a private cloud. So RAID 5 does a combination of striping and backup all at the same time. Well, it's not exactly backup, but it's like backup. We'll talk about it. And what happens is, let's say you need at least 3 drives. You put data on every time you write data, 2 drives out of the 3 will get data, 1 will get some backup or parity information. The next time you write the data will go on 2 different drives, and there'll be 1 that gets backup information, something to that. Well, because the drives are going to rotate. I'll show you what I mean in a minute. By doing this, organizations get greater speed and greater performance. So here's what it would look like, and maybe this will make it explained. So here's a traditional RAID 0 environment where the first time I write my data to the first hard drive, then I write my data to the second hard drive, then I write it to the third data, and then I write this backup data or parity data to the fourth hard drive. The next time I maybe store data on the first hard drive, then maybe the second hard drive, then I put some backup or parity data on the third hard drive, and then I put real data on the fourth hard drive. The third time around, I add data to the first hard drive, then some backup data to the second drive, then some data to the third drive and the fourth drive. The last time in this 4-drive environment, I write data to I write backup data to hard drive 1, and then data to the 2 drives 2, 3, and 4. Now, why is this an advantage? Well, if I lose any one of these drives, all we have to do is remove it from the RAID array, pop in a new drive, and the information that was on the missing drive is built back up from all this parity data or backup data that's sitting inside of all these other environments. So that's why RAID is good. There's also a RAID 6 configuration, which is a version of this, but it uses 2 parity drives. So that's why I said there's a lot of these that are coming out of it. So can't do this in the cloud, but you'll be using some of this as in the data center or a private cloud. So RAID 0, max speed. RAID 1, 100% redundancy. So that brings us into RAID 10. Now, RAID 10 gets pretty expensive, but gives us the maximum speed and the maximum availability. So this is cool stuff. So what is RAID 10? Well, we create a RAID 0 array because that gives us a backup speed. We create a backup RAID 0 array, and then we run RAID 1 or disk mirroring between them. So really good performance, really good backup, and this high speed and super high redundancy makes it incredibly popular amongst organizations like big banks or environments where seconds of downtime can mean millions of dollars. So here's an example of what that looks like. Here you've got a RAID 0 array for these 2 drives, and then you've got another RAID 0 array for these 2 drives, and then basically between them you're running RAID 1 or mirroring. So that is RAID. Now let's talk about file storage in AWS, and we will talk about the Elastic File System. So the Elastic File System is a scalable file system. It should be. I'll tell you what it is in a minute. So if I have 100 systems that all need to access data all at the same time, I put it on file storage. Maybe I have 50 servers that all want to share the same information. Stick it on a file server. So you have an opportunity to build a file server, say a Linux file server, and share a folder. And then you have an NFS file share. Or if you don't want to manage a server yourself, and you can create the Amazon branded version of the network file system file sharing service. So same kind of concept that we've been dealing with for decades. Just Amazon now manages these file servers, and they branded it so they stick the word elastic in front of it. So now you understand what is EFS. So it's a managed system. So what's the benefit of these managed systems? If you add storage, it's just going to grow dynamically for you, so you don't worry about running out of storage. So that's why they like to call it elastic. So when we talk about EFS, we're going to have two options. We're going to have a standard option. It's going to be your normal storage. It's going to give you good performance. And we have another version called infrequent access. What's that? Just like with object storage, you pay less to put it there, but you might need to pay to access it, that kind of thing. So we're going to have two options with our elastic file system, meaning Amazon branded NFS. We've got a burstable option, which is the default, which means you've got information and you burst, and as long as there's bandwidth, you can use it. And provision throughput, which is where you know what you're going to use and you plan it, and you're guaranteed to get what you've got. And if it matters, you're going to provision it, and you're going to know. It's not like you don't need to do capacity planning if you want to build a high performance architecture that actually isn't going to cost a fortune. So you want to know how to do this. So here's the key to remember with Elastic File System. Because it's like NFS, it'll be POSIX compatible, so you can use it with things that require that. It's going to be scalable, give you good throughput, as good as you're going to get in the cloud, and be relatively low latency. And it will just scale for you, so you don't have to worry about running out of storage. So realistically speaking, here's where you're going to use it. If you've got multiple systems that need to access the same file storage, like in this particular example, you see where you have this Amazon EFS. That could be a Red Hat system running NFS, or it could be a Ubuntu system running NFS, doing a file share. But then you've got to manage the server. But in this case, you're just having an Amazon managed file server for you. So EFS is a cloud-based auto-managed version of an NFS service. So that means NFS, which means it's going to be used by Linux and Unix systems. Okay, so because block storage isn't real fast, what happens when you need high performance on the network? So we'll talk about that in a minute, but let's talk about Windows file servers. So I previously said that Windows uses server message block, right? Or you can, which means that with a Windows server, it's by default. If you wanted to use a Linux system, and I have lots of my students do this from time to time, have a Linux system share files with a Windows system, you have to run server message block on a Linux system, which means Samba. But anyway, so Amazon has some fully managed Windows file servers for you as well. And what are they? Windows file servers that Amazon manages for you. So if you're in a Microsoft environment, and most enterprises are, and they think they have things that they want to use with Microsoft file systems like quotas or Active Directory, and pretty much everybody uses Active Directory, the Amazon FSx system will work because it is a Windows file server. They just manage it for you. And when you're dealing with Amazon FSx for Windows, it's going to provide encryption both in transit, meaning from the time it's sent to the times it's received, and at rest, meaning at storage. So this is a good option if you don't want to manage your own Windows file servers. So pretty much it's pretty simple. You basically create your FSx file server, you configure your file shares, and you're going to connect it to whatever your systems need it. So standard Windows stuff. The key to remember is it's fully managed. So you're outsourcing management of the server, which means things like hardware provisioning, patching, and backups they do for you. So it reduces the burden of managing a server. And when you outsource it to manage, it could cost more or less based upon your people costs and how you run it. But there is that. So because it's a Windows server, it's going to support server message block protocol. It'll integrate with Active Directory, which is pretty much the enterprise-wide identity and access management systems most use, and is also compatible with a distributed file system. So Windows applications, Windows workloads, this is a great file system to use in the cloud if you've got Windows servers in the cloud. The performance is, it's going to be based off of SSD storage, so it tends to be, as good as anything else you're going to get, but it can scale to thousands of concurrent connections. So is pretty good in terms of that, in terms of what you're going to scale out there for. So the key to remember is it provides data encryption in transit, so that's going to be great from a security perspective. It's going to integrate with the AWS identity and access management tools if you're using them, which will most likely be federated into Active Directory. It'll be integrated with the AWS key management system. And, these are standard servers, so they tend to comply with HIPAA requirements, GDPR environments, PCI DSS requirements, at least in the way Amazon manages them for you. They are replicated, the data is replicated across multiple availability zones for high availability, and it gives some good backup and restore capabilities against data loss. So in terms of how does that integrate with other services, that's the key. It connects so easily. So if you've got a hybrid cloud and you've got a direct connection and you wanted to access this stuff on the cloud, like the person asked earlier, when he asked, could you do access EFS? This is kind of that same kind of thing. This is the Windows equivalent of EFS. But it might be better to store your information locally, a lot higher performance, lower latency. So in an enterprise, they've got a lot of file sharing. This will take care of that. So, and the key is all those Active Directory things, all those quotas, you've got that because it's Windows servers. Lots of times people use this kind of thing to back up a database, especially in a Windows environment. You could use this type of storage for media and entertainment because it'll support like the kind of media workflows that systems would use that require high throughput and low latency. You can use this to serve web content across multiple servers at the same time. So how do you set this up? You sign up for an AWS account. You create your file system. And when you do that, you specify, say, the storage capacity, the throughput, and other configuration options. You integrate it with your Active Directory, or you create a new one for your permissions. You mount the file system wherever it needs to be. And then you just access it with a standard Windows tool. And you can manage and monitor your systems, of course, with the command line interface, the console, specifically the FSX console, or the software development kit if you want to do it over another system. Okay, so let's talk about another AWS service called DataSync. So lots of times you'll have an on-premise environment, you're going to have a cloud environment, you're going to have stuff. So how do you keep your data synchronized? Well, there's lots of ways to do data synchronization, but AWS DataSync does have their option for you, and that's going to be a managed service that's going to make it easy to automate and accelerate moving data between, say, on-premise and AWS. It can sync your data between different AWS storage services. So it's AWS's native tool. It's designed to handle large-scale data transfers. And what happens is AWS DataSync will enable you to automate the process to transfer your data back and forth. So less manual intervention, less custom scripting. It'll handle the complexities of data transfer, including, theoretically optimizing the network, validating the data, and error handling. And it works with multiple storage services, S3, EFS, FSX for Windows, FSX for Lustre, which we'll talk about, which is where you get to high performance, and Amazon FSX for OpenZFS, if you're familiar with that file system. It also works with NFS systems, so pretty much everything. Now, it does actually encrypt the data in transit, which is great. And again, at rest where it's going to be stored. And by doing that, it'll integrate with the AWS key management system to manage the encryption keys. And it can work with, AWS IAM controls for identity and access management, like who are you, what you're allowed to do, and then keeping track of what you've done. Where it can help with data validation and integrity because DataSync will perform data integrity checks to ensure that the data that's transferred is going to match the source. So you want to make sure that you're getting the right data. And it'll verify the data during and after the process. And that way you've got data consistency across your clouds, what have you. You can schedule it and automate it. So you can run scheduled transfers at say 2:30 a.m. to make sure that it's done at the time where the networks are at least used. So periodic data backup, synchronization, archival purposes, this is going to help you automate that. Now, when you're transferring data, sometimes you don't want to transfer everything. You may want to exclude certain files or include certain files or directories, or the patterns of where things are going. You've got that option too with AWS Datasync. So I'm going to talk about it here because, it's kind of hard to where you would classify this, but it's not really storage while we're going through the storage section. So keep that in mind. I'm going to talk about the AWS Migration Hub. And that's going to be a service that's going to be a single location that you can use to track the progress of your applications moving across AWS. It's going to help manage and monitor your migration process, and it's going to provide some visibility into the status and the metrics of each project. The last thing we talked about was synchronizing your cloud environment. So, in this case, with the Migration Hub remember, the key feature here is you've got a centralized dashboard. So you're going to be able to look and see what's being moved and how it's being moved, give you kind of that unified view. So it'll help with discovery and planning efforts with regards to migrations because it integrates with the application discovery service, which we'll talk about later at some point. We're just going to figure out which applications you have. It can help you group related applications to try to know which stuff that needs to be moved together. And it gives you the ability to kind of track the migration of applications, which is one of your bigger challenges when you move to the cloud, unless you do a lift and shift. And it'll provide metrics and reports. So, whenever we're doing something, we have to define what is success, right? And we need to know what's working. So we're going to need lots of details, like the number of servers that have been migrated, what percentage, what amount of data has been transferred, what errors and things we've encountered along the way. And this is going to help with that. So it's really about progress tracking. Track the progress. What's going on here? What's going on? Because these migrations can be relatively large, and they might need several program managers and a lot of people to do it. So kind of think about that. So Migration Hub also assists with automation and orchestration of certain tasks. So certain repetitive processes, if you can automate that, it's going to reduce the risk of manual effort and errors, assuming you know what you're automating. So now let's talk about the AWS Transfer Family. And that's going to be a fully managed service from AWS that's going to help you transfer your data from, say, your data center to the cloud. And it's going to support lots of protocols to make it easier to migrate, share, and integrate your data with existing systems. So we're talking about the AWS Transfer Family. It'll enable you to use, say, SFTP to securely transfer your files. You can use FTTPS, which is FTP with TLS encryption to improve the security. It also supports your ability to transfer files over standard FTP over an unencrypted connection. But if you don't have to use that, you probably don't want to in today's world. And it enables you to store things on, say, S3 or the EFS or the Elastic File System if it needs to be viewed by multiple systems at the same time. So these transfer family can basically help with data migration, move it to the cloud, share data with external partners or systems. And it's quite helpful for backup and recovery purposes and compliance. Okay, well, we are going to go into next databases. And we've got lots to talk about in databases, lots and lots and lots of getting geeky. So it'll be fun. So I'm going to stop now to see if there's any questions. How to detect ghosts, meaning in using AWS. I mean, how can we control the motion camera to detect ghosts using AWS? So honestly, I don't even know what you mean by ghosts. So I'm assuming it's a joke, but I really don't know. Though Chris does like ghosts a lot. As an architect, how do you do cost management for customers, speaking of AWS services? So you really have two things going into cost services. And I'll tell you why the cloud costs have gotten so crazy and why the cloud, David Lithicum's numbers, and they sound pretty accurate to me. Cloud computing costing about two to 2.5 times more than it would to do it yourself in a data center. So what goes into this? So what goes into this is as following. It is a matter of knowing what we should put on the cloud versus not put on the cloud. Because certain things, if you've got an application that runs 24 hours a day and it's heavily utilized, it'll cost you a lot more to go serverless than it would be to put it in a monolithic application sitting in the data center or the cloud. And it would be cheapest on the cloud if it runs hard. Likewise, we've got a sporadic event-driven application, and it's sporadic, not paying for systems to run using a serverless environment and only paying when we need them. If it doesn't run a lot, it's going to be very cost efficient in the cloud. So the first part of cost management is knowing what to move to the cloud versus what not to do. And if you don't understand the network in the data center, you won't know that. So there is that. Next, you need to really understand your system. So this is where capacity planning comes into play. If you know that in your data center and you've got a retail and you're a global retailer, for example, and in your data center, you've got a website, and that those web servers are utilized at 6% all year long in your data center, but then they go up to 100% during Christmas because that's the busy time of the year near Christmas. Then when you go to the cloud, you don't put those same systems on the cloud. You use something where they'd be running at, say, 70% versus 6%, and then you let auto scaling do its job. And if you know what your systems are, you can say, I'm going to reserve this system for the next 3 years and get a discount. So there's some of that. But a lot of it's knowing what not to put on the cloud. Certain things are just going to be 10 times more expensive on the cloud. For example, if you're just hosting a few virtual machines, I can go to Dell right now, and for about $300,000, I can buy a server with 2 massive AMD EPYC processors, each with 128 cores. I can put about 6 terabytes of DRAM, and I can put an NVMe RAID array. And if I were to use that same system on the cloud with similar storage performance over the course of 3 years, I'd be paying several $1 million versus a few $100,000 to buy it from Dell. So knowing if I've got something that needs that performance, don't put that in the cloud is the key. So the next part of it is designing the architecture right. So if we know what we're designing and we know what the end business goals are, we're going to make sure that the costs are going to be optimized. Then we have to really think about it. And the reason we're hearing so much about cost optimization right now is the majority of the cloud architectures that are there are really bad. And what do I mean by really bad? 50 to 70% of all cloud architectures companies have spent a lot of money on and gotten no business benefit. So that's why people are complaining about the cost. If I were to give you if an investor said, give me $100 and I'll give you $1,000 back, I'd say, how often can I give you $100? And I'd buy more of it. If I gave somebody $100 and $1 came back, like most people with their cloud investment, then I'd be really worried about cost. So it's less of what the cost is, and it's more about what the customer's actually getting from what they're spending on it. So you need to be very understanding of your customer's business so that any technology that you actually implement actually helps their business, and you'll be in a much, much better shape for it. So then it's using the right service. If you understand your applications, you know when to go serverless and when not to go serverless. So that's really the key, using the right size systems, knowing where the company's going and knowing how to deploy it correctly, and knowing how and where to place your systems and which technologies are there. Now, I'm going to tell you right now, what I just told you, don't think that's done in one day. Don't think that's done in 1 week. And don't even think that's done in 1 month in a big global enterprise architecture, like the kind of architecture I would work on, or a David Lithicum. This could take 6 to 12 months to figure all this stuff out. So it's not like in a certification where you think you're going to get asked somebody about a WordPress website and they're going to come there. We architects work in companies that have hundreds of thousands of employees and data centers all over the world and work in billions and billions of dollars a year of revenue. That's why they pay people like us to design their systems. So they understand it's going to take a fair amount of time to get this. So there's that. And then the rest of the cost management is once you've deployed the systems, you monitor these systems. And can you reduce the size of systems? Do you need to provision systems? Okay, you're using more capacity. Can you reserve it? We put this application on the cloud, and this one on the cloud is costing us way too much. Can we bring it back to the data center? So that's really what you're talking about. How do you explain AWS services pricing as an architect? You don't. So here's the key. As an architect, you are in sales, yes, but you also have to be a trusted advisor. So one of the ways of not being a trusted advisor is to let the sales rep or the account manager talk about the pricing, and you don't. And that's why, for the most part, if someone goes to a physician, the physician doesn't collect the co-pays or the money from the patient. They have the receptionist do it or a billing person do it. So you don't explain AWS service pricing. Your account manager discusses the service pricing. You will be there, parts of the negotiation, but you focus on what you can do for them. You focus on what is the return on investment capital that the organization is spending. They're spending money. So what's it going to do for them? So if you analyzed an airline's purchasing fuel cost and you find that they can save, $3 billion with some tech, and the tech costs $1 billion, they're going to buy it. If you did the business case and looked at the tech and said, yeah, we can figure out when that airline can purchase fuel price contracts to get the cheapest price, but the tech costs you $50 million and it's going to save them $1 million a year, you don't invest in the tech. So you focus on what you can do. You focus on what that architecture does for them. You focus on how it improves employee productivity or product output or optimization of the supply chain. And you let the pricing people talk about the pricing. And that way you stay a trusted advisor. Because the second they know that you are too concerned about price, that's the second, they view you as sales. And then they don't trust you. And the real thing as an architect is you need to be able to tell a client, this is not right for you. I've done it. I've done it numerous times where a client said, should I do this? And I say, I can build it for you. And if you want it, we'll give it to you. But I don't think this will help your business. I don't think it's in the best interest of you. And in the end, they thanked me and, they called me back and said, Mike, design what would be in the best interest of me. And I was happy to do it. And then they wanted it anyway. But you got to really treat the end customer the way you'd want to be treated. And if you do that, you'll be good. And I'm saying this because the architecture world is very small. There's not a lot of us out there and we all know each other. So kind of keep that in the back of your mind. And that's an incredible question. And I'm glad you asked it, Kabenga, because if you didn't, we wouldn't have been, it's the kind of thing that you don't think about. And I hope that really helps. Data architect will reduce the spend. Data is one of the services that cost a lot, right? Well, everything in the cloud costs a lot. Networking in the cloud costs a lot. Normal networking, I buy a connection from point A to point B. And if it's 10 gigs and I don't use it or do use it, I pay one fee. When you were dealing with data coming in and out of the cloud providers for a while, not only did you pay for the 10 gig link, then you had to pay a daily penalty called the port fee to have the link. And then they actually charge you to use the link that you already paid for. So, that gets expensive. A server on the cloud right now, you can get an AWS i3 instance. And if you max out all the cores, it's going to cost you about $1,100 bucks a month. You can go to Amazon right now and buy that same server refurbished for $400 versus $1,000 a month. So, knowing what to put on the cloud in there, everything on the cloud is going to cost more. But data is important. Data is a place where the organization spends money. And, optimizing data because the data architect did it in a right way is definitely good. And yeah, regarding Ghost, actually, Sapiro, Chris loves Ghost too. So I totally with you 100%. And I'm going to get back to the content. So for Basan, I am not a DevOps engineer, and DevOps and architecture are very different from each other. But DevOps engineers will have a lot of coding in their world because they're merging development and as well as operations. I can recommend not going towards sysops if unless you want to do the maintenance on the systems. There's nothing wrong with sysops, but it's the lowest paying technology career out there, or one of the lowest that are out there, and it's going to be as much work, if not more work, than it would take you to become a DevOps engineer. So something to think about. And we've got a video on why we don't recommend the AWS SysOps certification. I would watch that as well. Okay, so let's get back to the content. So before, databases are pretty big. So I need to know that you're awake, you're alert, and you're oriented, because not only are we going to talk about the AWS, the little stuff they would put in their certification, we're going to talk about relational databases. We're going to talk about NoSQL databases. We will talk about the features and functionalities of the main databases that you can use in a multi-cloud environment. And we're going to have fun with it. So it's going to be a lot more, about 4 or 5 times more than you would normally get in a certification, because I want you to know something. So give me a hashtag AWS so that I know you are awake. Okay, so let's talk about databases. So to begin, what is a database? A database is going to be an application that allows you to store a lot of information. The key here, which is different than databases other than just throwing stuff in a drawer, is the database makes it easy to look at your data, sort your data, run calculations off of your data, report off of your data, or share your data. So it's the exact opposite of like throwing everything in a drawer and trying to search for it. You can think of the database as these beautifully organized things that you can help find anything. And in today's world, databases are absolutely critical to modern applications. So AWS will have basically 3 kinds of databases, and we'll also talk about data lakes later. They will have relational databases, and we will talk about what they are. They will have NoSQL databases. They will have databases that are used for data warehouses, and we will talk about data lakes as well. So let's talk about relational databases. So what is a database? What is a relational database? First, I'm going to tell you right now, it's the most common form of database. And it provides storage for information that's related to each other. And data is, for the most part, stored on a spreadsheet. It's like stored the way it is on a spreadsheet. You've got rows and columns. So very structured. Now, relational databases adhere to this concept of an ACID model. And it's an acronym that stands for atomic, consistent, isolated, and durable. And what does that mean? It means that when a transaction occurs in a database, it either occurs or it doesn't occur. It's an all or nothing thing. That the second I write something into the database, every other database in that system has the identical data in it. So it's immediately consistent. It's isolated, meaning that one transaction will not impact another transaction. And it's durable, which means the data in the databases will not be lost. So Amazon's going to support a lot of relational databases. They have their own proprietary Amazon Aurora, and we will talk about that. We will also talk about MariaDB, which is another common database. We'll talk about Microsoft SQL Server. We'll talk about MySQL. We'll talk about the Oracle database and the Postgres database. So think of the relational database as a very organized structure, columns and rows. And what happens is the databases will have tables that is going to be very structured so you can see how things that are related to each other. So here you can look at this. Pretty simple. We can see the customer's name, their email, what they paid for something, their order information. And this is going to give business lots of information. Maybe they find that at a certain price, they can sell more than at another price. So, there's a lot of things that organizations are going to get from relational databases. So the key to remember is we've got tables. And tables are going to be the primary structure for storing the data. And they'll consist of rows and columns. Each table will represent a specific entity, such as customers or orders or products. And regarding the rows, and a row you typically may hear it as a record. Each row will represent a single instance of the entity, whatever that entity may be. So each row could be a single customer. Now, regarding the columns, each column will have a field that'll represent an attribute. So maybe it's the customer's ID, for example. And with databases, we'll typically have a primary key, and that's going to be a unique identifier for each row in a table. And it's the primary key that's going to ensure that each record can be uniquely identified. Databases may also have something called the foreign key. And this is going to be a field or a collection of fields that are going to be in a table that will uniquely identify a row of another table. So if you've got two tables, it's going to establish a relationship between them. And we can have relationships which are defined connections between two tables, usually through either primary keys or foreign keys. And, when we deal with this, it's like anything else where we can have a one-to-one relationship, a one-to-many relationship, or a many-to-many relationship. Now, the key with relational databases is they use a common language, which is great. So when you want to query or pull information out of the database, they use this concept of a structured query language. Makes it very simple. So there's SQL commands for querying data, updating records, and managing the databases. And for the people that use these systems all the time, they need to be querying them. As architects, we don't run SQL queries, but we may have a cloud engineer or a DevOps engineer that's going to be querying this stuff, or a data engineer or a data analyst that's going to be running SQL queries all the time. So the key to remember, we talked about the integrity of the data. Relational databases make sure that the data is consistent through a bunch of constraints. And relational databases, the tables on them are relatively flexible. We can easily add or delete or modify information without modifying existing applications. So we've got some flexibility in the way we manage data with these databases. And relational databases often can scale fairly well. They can scale vertically by adding a lot more power to the server. And some relational databases they all have some form of horizontal scaling by adding more servers, but it's not going to be the way you think. It's not like scaling a web server where you just add a load balancer, but that's okay. We'll teach you how to do that as well. Let me get to that. Now, relational databases tend to be fairly secure. They've got lots of security features, like things like identity and access management. You can authenticate to the system. You can encrypt the system, use any kind of permissions you need. The data is independent, meaning if you make a change to the database schema, it's not going to affect the data access methods. So you can evolve your applications over time independently of the database's actual structure. So I'm guessing you're starting to see that's why these systems are used so widely in business. So where do we use them? We use relational databases in e-commerce. So got a product catalog, it's in a relational database. Customer information in a relational database. Orders, inventory, probably in a relational database. In banking, every time you use your ATM card, something's got to handle those transactions, goes to a database. Your financial records, typically in a relational database. Your customer accounts, typically in a relational database. In healthcare, maybe some patient records could be stored in some, integrated into their electronic health record. Appointment scheduling could be there. Education uses them widely, student information, course enrollments, academic records, it's there. So if you want to hack into the academic records and change your grades to all A's, well, I'm not recommending this, but that's what you're really hacking into. And all those movies were the people that did that. Governments, tax records for citizens, tax information, public services. So these things are used everywhere. Now, the first database I'm going to talk about is the Amazon branded one. I'm going to be straight with you right now. If you have a multi-cloud architecture, don't use this. Use something like an Oracle database or a MySQL database or Maria database or a Microsoft database that you can stick in all different clouds. Because if you use this Amazon Aurora, it's kind of like me speaking Greek and Chris behind the speaking English, and Chow on the other side speaking Vietnamese, and Mo speaking Arabic. And when you translate information, some things don't translate. For example, I say please close the lights. In America, what does that mean? They say shut off the lights. So the problem when you use different databases, in some cases, it's going to be hard to integrate these systems. So in a multi-cloud environment, don't use Amazon Aurora unless there's some specific reason to use. So use something else. And remember, 98% of organizations are multi-cloud. So think about how often you could use this. Less than 2% of the cases in most cases. So just keep that in the back of your mind. So Amazon Aurora is a great database. It is an awesome database, though. It is an Amazon fully managed relational database. And it is Postgres and Microsoft SQL compatible, so it makes it relatively easy to get your data into it, but you're not going to want to run these systems side by side across different clouds. It scales. It's a great database. So what they tried to do is make it more like the Oracle database, more of an industrial database. So over a free thing like a MySQL. So they say it's 5 times faster than standard MySQL. They say 3 times faster than Postgres. That's the marketing numbers, but it's a great database. So it gives you some of the benefits that you would get with, say, an Oracle or a commercial database, but lower costs of like a open source database. But it's still useful in enterprise applications if the organization's only going to be on a single cloud. So like as a software as a service application. It's a good performing database. It's got good performance. And, they've really designed this very well, good storage system, highly distributed fault tolerant system. It's a great database. It really is. And if the world wasn't multi-cloud, we could use a lot more of it because it's a really great database. It tends to scale well, anywhere from 10 gig of storage to 128 gig with no downtime. You can scale at read capacity fairly well, and you can put up to 15, read replicas in it and multiple availability zones. So it's a robust database. It's designed to provide 99.99% availability. That may be okay for a business, or that may not be. Banks, hospitals, emergency services systems need to have 99.999% availability versus not 99.9. But it's a great database. And it's not that hard. It doesn't take that much to take your data and move it into these things if you're in MySQL or Postgres. But trying to keep 4 or 5 of these up and running at the same time and synced would be challenging. That's why people would be more likely to use a more open standard one. The key to remember with Aurora is it's managed. So what does that mean? It means you don't have to think about, provisioning it, patching servers, backing it up, recovery, scaling, because it's all done for you. So with a managed service, you lose a lot. You lose control. But it's done for you. So that's a trade-off. And architecture is the process of choosing trade-off. Is this the right thing for me? I lose this, but is it best for me, or is this other option good? So you're picking the best choices. Security. It kind of makes it easy to do your security if you're just in AWS, because it provides encryption at rest and in transit, and it integrates into your AWS identity and access management because it's all AWS stuff. And when you go with single proprietary things, it locks you into a vendor and makes it harder for you to do multi-cloud and potentially harder to innovate in the future, but it makes it simple. So always is an architectural option. So you might use Aurora with a web or a mobile application. You might use it in e-commerce, any place where you use a relational database. If you don't want to manage servers, you can use this in AWS. So good database. It's got a pretty interesting distributed storage architecture. So, it's decoupling your servers from your storage from your compute, just like on a block storage environment. but the storage kind of grows as you need it. So you don't have to think about exactly how much storage, which again makes life easier with a managed service. It like most of the AWS databases, it will back up your data, but this one continuously backs up your data to S3 and allows you to create your manual snapshots if you want for a point in time recovery. And you can restore your database from these backups or snapshots anytime you need. And because it's AWS, it's pretty elegant in the way that it integrates into CloudWatch, which is logging, CloudTrail, which is auditing, and the management console. So pretty easy to use. Okay, so that was the proprietary Amazon one. Great database, but you can't run it in Azure. You can't run it in Google. So if you're in two or more clouds, it's going to be challenging. So now let's get into the first of the open standards databases. MySQL. You can use this in any cloud provider you want, or data center you want. And MySQL is probably the most popular open source relational database management systems in the world. It's used in a wide range of web applications, enterprise solutions. It's highly reliable. It performs relatively well, and it's pretty easy to use. And while it started out, I think it was with Sun Microsystems or even free, even open source freeware, it's now supported by Oracle. So it's got, people that know data and databases behind them. So it's got good support on it. So it's a relational database. So that means it'll support, the rows and columns of the way you store your tables. It means you'll run structured query language queries on this. It means it's an ACID compliant database, which we talked about. And here's the thing. It's got all kinds of cross-system support. Runs on Windows, runs on Linux. Heck, you could run it on Mac OS. Not that you're going to put any server in the cloud on Mac OS, but the point is it runs on anything. So it supports multiple storage engines as well, like Database by default, but there's other things like MyISAM memory. So you can use different storage engines based upon different use cases, and your database people you're going to want to work with that. It provides regarding replication. It's got lots of replication methods, master slave, master master, group application, and that just refers to how these systems are sent out there. And this gives you the opportunity for high availability and data redundancy. Regarding scalability, there's others that scale better than MySQL, but it scales very well. Pretty large databases with high concurrency workloads. It's got good security features like user authentication, access control, and encryption. It's used in a wide variety of web applications. So, you'll see it all the time for dynamic web applications, content management systems, e-commerce platforms. There's even some people that do warehousing and analytical applications on MySQL, although more often it'd be Postgres. It's used in a wide variety of enterprise applications that needs a reliable database that's efficient. It can use lots of embedded applications because it's fairly efficient code with a small footprint. And it's open source, so it's free. And there's a wide active community that supports it. So that's MySQL. Been around for a long, long time, decades, and it's free. So the next one we're going to talk about is Postgres. And it's technically PostgreSQL, but, people typically call it Postgres. And this one is a database which is known for its emphasis on extensibility and standards compliance. And it's widely used in academic settings, industrial settings, because it's robust. It's often used as a data warehouse. It's a relational database, so it's got that ACID compliance, which we initially talked about. And it's pretty standards-based. It adheres very closely to the SQL standards. So most, SQL 2011 things, if you've seen that out there, features are supported. Regarding extensibility, it allows users to create some custom data types and operators and functions. And it supports all kinds of data types like JSON, XML, HStore. So lots of opportunities in the way the data is structured as well. Concurrency control. So it has this concept of multi-version concurrency control. So it can handle multiple concurrent operations without locking up the database. Some databases have to lock until the next transaction needs to occur. This can do them both at the same time. And it supports all kinds of replication, both synchronous and asynchronous. So logical replication for maybe fine-grained control over the data. So it gives you lots of tools with regards to how and where you're replicating your data. It has very good full-text search functionality, so you can run some powerful search queries. And there's geospatial support. So there are certain kinds of geographic information systems that are out there, and this tends to integrate fairly nicely with those systems. Used in plenty of backends for web applications, but because it handles complex queries and very large data sets, it's widely used for data warehousing, and we're using data warehouses for business intelligence. Gather insights from our data to guide the business into making better business decisions. You often see Postgres in financial applications because it's so robust in its processing abilities. You often see Postgres in scientific research. You got a lot of structured and data that you're popping into something like Postgres, and it's a little more flexible on some of the other data you can put. And let's talk about some good things about it. It's open source. It's freely available. It's got a strong and access community, and it's very high performance, and it's got lots of optimization features. So this is a big database out there, especially with regards to data warehousing. It supports, authentication, authorization, encryption, and auditing of the database. It tends to scale fairly well. So Postgres, very common relational database. You can use it on any cloud provider you want, any data center you want, all three at the same time if you want, just like MySQL. Now, another free open source database supported by AWS and pretty much anybody who want to put it is MariaDB. And it's open source, and it's created by the people that made MySQL. So the goal with MariaDB was to improve the performance and functionality of that they started with MySQL and improve upon it. So, that's kind of what we're typically talking about here. Is MariaDB is going to be highly compatible with MySQL. So matching the APIs, commands, and data structures, because it was made by the MySQL people, they wanted to make it smoother for people to migrate over. And it works with a tremendous number of storage engines like InnoDB, MyISAM, ARIA, Column Store. So lots of options and functionality here. Tends to perform a little better than MySQL. And it's got some extra features like thread pooling and some advanced optimization. And it's got better replication capabilities as well. Tends to be fairly secure with encryption, user roles, and enhanced identification methods, so to speak. Tends to scale relatively well by bigger servers or adding more, like read replica type servers. And it supports all kinds of replications. So another good open source database. It tends to be very extensible. So you can create plugins to it with various storage engines to extend its capabilities. And it's got a very strong community because it's open source that maintains this. Where might you use MariaDB? I'm hoping you're starting to sense a trend with these things. They're used in a lot of the same places, which is why I keep going over them. Web applications, the backend database, data warehousing you can use because it tends to scale well. Any kind of enterprise application that requires robust and efficient data management. Embedded applications is relatively small, just like MySQL, so small footprint. And it's an open source database. So we've covered these. Now, the last ones we talked about were open source. Now, this is not an open source database that we'll talk about next, but it will work in all cloud providers because Microsoft has their SQL server And Microsoft SQL Server is used for Microsoft workloads, and Microsoft workloads are a lot of what's going on out there. So let's talk about Microsoft SQL databases. Amazon supports, the majority of them, like SQL Server 2008, 2012, 2014, what have you. Good support. And if you're running Windows workloads, you're going to probably need an Microsoft SQL Server. So you can run them in pretty much all your cloud providers. There are about 4 versions of Microsoft SQL databases. There's an Express, a Web, a Standard, and an Enterprise. But you can think of it as Microsoft's relational database management system. So when you've got a Microsoft workload and you want to store, retrieve, and manage your data, you'll typically use Microsoft SQL. Scales real well. Lots of security features as far as Windows goes. And it integrates with other Microsoft services. Relational database engine. But they have this TSQL. They call it Transact SQL. And that's going to be an extension of SQL that was developed by Microsoft to give you additional procedural programming capabilities. It tends to scale very well with regards to high availability because they've got these always-on availability groups and database mirroring and log shipping to ensure good availability and disaster recovery when needed. Regarding security, it's got encryption, row-level security, dynamic data masking, and even integration with Active Directory. So it's going to integrate with your Microsoft authentication system, which is perfect when you're running Microsoft workload. So there's some integration services, which is going to be a platform for data integration. There's typically reporting services that along with this that you typically get, which is going to be a server-based report for generating software system. You're going to have an analysis service, which is going to provide online analytical processing for data mining type functionality. It tends to integrate well with some machine learning services, specifically the integration of Python and R scripts with SQL Server. In-memory processing, because it tends to do in-memory online transaction processing, and it has a column store indexes to give you better performance for transactional and analytical workloads. You'll see it in a wide variety of enterprise applications. Anything that's got robust data management, high availability in the enterprise that's Windows-based, you'll see this. It scales, and it scales well, so it's widely used as a data warehouse. And it works with, your typical ETL, extract, transform, load processes and type analytics. And it integrates with, business intelligence tools like Microsoft Power BI. So it gives you a really good information to be able to store the information, retrieve the information, and visualize the information. So it's a pretty big database out there. You may see it in web applications. So web applications that were built on the .NET framework typically use this. It could be used for financial applications as well because of the transaction support. So when would people really use this? Where is this advantage? Well, for Microsoft shops that are running, Microsoft servers and Microsoft desktops, and they've invested in the Microsoft programming infrastructure like .NET, this really is going to shine. It's got good performance and it scales. Now, we're probably going to go to next, the king and the queen of all databases, which is the Oracle database. Oracle's been out there for decades in databases. Probably the most popular, if not one of the most popular enterprise relational databases in the world. It has an extremely extensive feature set and functionality. It's developed, licensed, and managed by Oracle. Amazon supports multiple versions of the database, Standard 1, Standard, and Enterprise. Of course, there's nothing to ever stop you from just putting your database on a virtual machine, copying it over from the cloud, and running it on an EC2 instance. But this is the Amazon's, database management systems that, you don't have to do that with. So there's 2 versions of licensing supported by Amazon. And this could pop up as a question. So the 2 options are Standard Edition 1 and Standard Edition 2, or you can bring your own license. And that's if you already have a license for the database. You've got some license flexibility, standard, enterprise, enterprise 1, enterprise 2. But, Oracle database, you may hear it called Oracle DB. This is a very powerful multimodal database management system. It's used everywhere because it's so robust, high performance, and its features are so good. It's a multimodal database, so it'll support relational, document, graph, and key value models, allowing you to store and manage a whole lot of different types of data. This thing scales vertically, it scales horizontally, it can handle giant volumes of transactions and data. It's got very high ability platforms because you can do these real application clusters. It's got Data Guard and Golden Gate. So there's lots of things here to make these systems run high availability. Its performance is great. They've got some advanced automatic storage management in it and partitioning and in-memory processing. So this is what you're going to put in a big load enterprise application for an organization that's got budget for it. Got lots of security. You've got really fine-grained access control. It's even got a database firewall with it. Lots of encryption. And it integrates very well with other Oracle products and a lot of third-party applications because this is such a popular database and so many enterprises use it. Integrating into this is going to be relatively easy. So you'll see this constantly in banking and insurance and financial services organizations. You'll see it as the data warehouse because of its ability to scale and its analytical capabilities. Any kind of big enterprise application, you'll see this. Telecommunications, for example, think of the amount of data that's generated in telecommunication networks. Like every time somebody places a call or a text or that, it's logged somewhere. You could use something like this there. But people use it because it's robust, it's high performance, and it's got a big feature set. And they've got somebody they can call, Oracle. So huge community of support, lots of data models, very flexible. On-premise, hybrid cloud, multi-cloud, people can use this. So that is relational databases. The next content I want to talk about is NoSQL databases. So I'm trying to think if we should do that. How we do that. Chris, there are a lot of questions there? Because if there are, I'll go to questions for the next 18 minutes. Otherwise, I will go and spend about 20 minutes on this. And bear with me, my team lets me know. Okay, so let's do this. I'll go over some NoSQL databases, and then we'll get to some questions. So we'll talk about NoSQL databases, or not only SQL. These are not relational databases. They are designed to handle a wide range of data models that go far above the limitations of a relational database. The relational databases are designed, typically speaking, for structured data. NoSQL databases, by comparison, have very flexible schemas, meaning you can get very creative with what you use. So you can store huge volumes of structured data, unstructured data, semi-structured data. So where you're at in the middle of a Netflix movie, great place to store this. My brother plays video games and he stops a video game and he can come back and he's in the same place. NoSQL database. That is where these kind of things play in. So NoSQL databases typically follow a key value pair structure. So things are kind of stored in that typical environment. But the key here to remember is that the schema is very flexible. You can change it, modify it, delete a structure, for example. So The next thing to remember is because these things are flexible, and because they also are a little flexible with regards to when you store data. Like on a relational database, we said they were consistent. As soon as you store a transaction, it's immediately available in any other databases that are participating there. In this particular case, what we're talking about is much more flexibility. And if I store data in a NoSQL database, it might take a second or two for all the other databases to synchronize. But think about it. Instant means really hard work on the databases. Doing it a little inconsistently over a little bit of time, well, then, that's where these are going to scale. That's another thing that makes it scale. So let's talk about some data models. NoSQL databases will support a wide variety of data models, including document models, key value models, graph models. And, there's this concept of the CAP theorem, where it's consistency, availability, and partition tolerance. NoSQL databases will give you the ability to prioritize, 2 or 3 of these properties. So by doing so, if you make the consistency a little less, you can scale a little better. You can make it more consistent, then that's going to cause a performance issue. How you would deal with partitions, how you would create high availability, all that's going to determine the workload on these systems. Now, how is data stored in a NoSQL database? Lots of different ways. Some use a format called JSON, some are XML, some are BSON. Each document can contain nested structures. So an example of that would be, say, MongoDB or CouchDB. Lots of times these are used as content management systems for a user profile or a catalog. We've got key value stores. So we can store data as key value pairs, where each key is going to uniquely map to a specific value. For a Redis cache, for example, would be this way. DynamoDB would be this way. So RIAC would also be this way. So this is good for caching or session management or real-time analytics. You can also use a column-friendly store and store data in columns and rows, allowing efficient storage in large data sets. Apache Cassandra is a good example at HBase. And we typically use this with time series data or big data analytics. One of the coolest things about Apache Cassandra is it's made to run on commodity servers. Add 50 servers, these things will write to all 50 at the same time. So really great when you've got a lot of write load in Apache Cassandra. Under the guidance of NoSQL databases, we also have graph databases as well. And these store data as nodes, edges, and properties to represent the true relationships between the data. An example is Amazon Neptune or Neo4j. These are typically used for social networks or recommendation engines or fraud detection. So let's talk about why people use these NoSQL databases. They scale and scale and scale and scale. They are very flexible. So you don't have to be so structured, and that's why you can use them for so many different things. They perform real well, and they support a whole lot of different data models, so you can choose the best NoSQL database based upon your needs. Where do you see NoSQL databases? Big data. So imagine having millions of Internet of Things spewing data all the time. Imagine storing information in social media. Imagine every Instagram post, for example, and is what do you call it? A NoSQL database entry. Think about something like that. Real-time web applications, online gaming, online chat, NoSQL databases. Content management. Imagine you're a company that's got a huge amount of unstructured content, blogs, articles, and media. Again, NoSQL database. Beautiful use case. E-commerce. Storing a product catalog or customer data or order histories. Big. In social networks, managing your connections and your interactions and making recommendations of other users. use case for this. So NoSQL, flexible schema, dynamic data structures. Compare it to an SQL database, fixed schema, so predefined tables and columns and structures. NoSQL, add more servers. SQL Server or a relational database, typically speaking, add a bigger server and then add replicas, caching, queuing. And we're going to talk about how to scale a relational database tomorrow and a NoSQL database. Let's talk about data integrity. NoSQL typically prioritizes availability or partition tolerance over immediate consistency. SQL databases enforce that atomicity, consistency, and isolation and durability, so instantly consistent. And then let's talk about the complexity of the queries. NoSQL databases have limited support for complex queries and joins. SQL queries, by comparison, support complex queries, joins, and aggregations. Okay, so I think we stop here and take a few questions. Tomorrow, we will get into the various NoSQL databases, and I promise you, we will get into more than just DynamoDB. So let's see if there's any questions. When creating a 3-tier architecture, is it possible to use RDS and S3 together? So imagine it this way. You have the relational database that's storing transactions in your 3-tier architecture. And the relational database uses what? Block storage. But you might have, for example, static content for the web. You might have some web servers, say EC2 instances, or a virtual machine sitting behind a load balancer for dynamic content. You might have static content sitting in S3. So you could be using S3 to serve the web content, and then you would say have some of the static web content and in a virtual machine for the dynamic web content. And then that intermediary layer, that business tier layer or that application layer, the business logic would run an application server. So yeah, we could use them all. It's just a matter of using them in the right use cases. Which database would I recommend as a universal database? This is a great question. So I'm actually glad I learned internal medicine when I was younger before I moved into architecture, because I learned there that there's millions of medications that are out there, and it's about choosing the right medication for your patient's condition. And two patients, one patient might be allergic to one medication, and another one might not be. One person's body may be different and require a different medication. So I will never recommend any universal application, because you have to evaluate the business needs before you know what there is. So the most dangerous thing you can do, Gabanga in tech, is become, I'm going to choose this. And what happens is then you become a hammer in search of a nail, and everything to that is. So I want you to learn this. There's no such thing as the best technology. There are many businesses now that are investing heavily in mainframe because they are so good at what they do. There are businesses that are leaving the cloud right now to go back to the data center for good reason. There are businesses that are running to the cloud. There are people that went to DynamoDB and then realized that they needed something different. There were people that went to the cloud and had block storage performance and then had to figure out something different. So what I want you to think about is this way. What problem are we trying to solve? And then what tool do we use to solve it? So if you were going to do construction, my brother has different kinds of screwdrivers, and he uses small screwdrivers, and some with an X on it and some that are flat. There's other things that he uses for bolts on my car. You have to use the right tool for the right job. So every use case will dictate it. I love that you asked that question. So I really want you to think about that. The same way that a physician can say, everybody gets azithromycin for every medical condition. You have to evaluate the needs of the organization, their goals, the strengths and weaknesses of every single opportunity that you have, and then you have to pick the best based on the traits. How does a multi-availability deployment provide high availability with synchronous replication? And how will read replicas provide scalability with asynchronous replication? So tomorrow, Preb, and I'm glad you're asking these questions, I will talk about how to do read replicas and how to do caching and how to use queuing. But today, here's what I want you to think about. If you have your database in one data center and something happens to that data center like a fire, and that data center goes down and your database is only in that data center, you've got absolutely nothing. But if your database is in two different data centers and one of the data centers goes down, you're still good. Now, if you're in two different data centers on the cloud, or even three different data centers in the cloud, and the cloud provider has a major routing issue or a major security event or a control plane failure, you're dead no matter how many availability zones and data centers you are. And that's one of the drivers behind multi-cloud. But the way they do this is when you have your databases into availability zones, they do synchronous replication. So that is going to be replicated in real time. So one availability zone or data center goes down, the other one can instantly pick it up. Now, read replicas typically do asynchronous replication. And the data replicated to the read replicas is often going to be slightly delayed, not real long, slightly delay. And that can enable the systems to handle the read traffic and reduce the load on the primary database. Hope I answered your question there. If not, you know how to find me. How does asynchronous replication support consistency? That is a great question. So when we're dealing with asynchronous replication, to some degree, it's eventual consistency, meaning it's not instant. So there is going to be a small, minute period of time where there's a lag in that. So it will be consistent over time, but not immediately consistent. So it might take a second to synchronize from the primary. You're thinking down the right direction, though. I like that. What are some of the disadvantages of using Mac OS for the cloud? So I really want you to understand a couple things. So when we're in the cloud, we're going to put our servers there. And what is a server? A server is going to be a very high availability device, meaning it's going to have multiple power supplies. So if one power supply goes, the server can stay up on power. It's going to be plugged into the network in a couple places. It'll have a special kind of DRAM. So when you have a server, it uses error correcting RAM. So if the server experiences a memory error, it'll fix that memory error dynamically as opposed to your system crashing. So that is a server. Apple does not make any servers. So that's one problem. So there's no such thing as a high availability Apple device in today's world. The Mac Pro that they used to make with the dual Xeon CPUs and error correcting RAM, that was $60,000 to fully spec out. That was a server grade system. But most Macs are not server grade. Secondly, Macs, you can't buy anything with huge capacity. What are you going to buy, a Mac Mini? So there's nothing with regards to server capacity that's there. Now, they do have these little dedicated machines that you can use on AWS if you want to compile code for a Mac. So there's that. The next issue is almost nothing runs on Mac. I mean, nothing's on Mac for the most part. What's it, 13% of the computers that are out there? So now you're going to put yourself in a weird environment. Most servers in today's world run on Linux. Most. Some servers run on Windows. So you're going to run your applications on something that you're really going to need to work for the majority of your users. So that's kind of the main reason. It goes to cost, performance. And here's the thing. I had multiple Macs and Mac Pros and even the highest performance workstations, and they couldn't meet the needs that I have. I had to get rid of all my Mac Studios that had 40 cores in there and things like 24 cores in there. It just wasn't strong enough. The GPU performance was there. So it just didn't work for my needs. And Macs, one of the good things about them is that they tend to work really well because they're locked into a specific ecosystem. They only work with a certain set of partners. And that's how Apple keeps their systems fairly reliable. And that's not a bad thing. Business systems have to support technology that's 20 years old that's still there. You'll go to many banks that have an old mainframe that they can't get rid of because it's critical to business and nothing else can do it as well. So when it comes to enterprise business, it's not about what's cute. It's not about what's fun. It's about what's going to work. And that typically means not Mac OS. Although there's applications for Mac OS in the cloud, there really is, but you're not going to probably put your database in there because you can buy a Mac for $8,000, but it won't perform as well as something else that you could get at a much lower cost. And I love Macs, and I used them for 20 years straight. Okay, well, if that is all the questions we have for today, Mark, thank you so much. Another great day of content delivery. Thank you for when you said good use of analogies to reinforce the content. I am so happy to hear that. Adrian, thanks so much. Preb, thank you so much. I'm always so grateful and happy to see you. Plus, I love cats, and the name Lion is just awesome. Okay, so if you've had a good time, can you give the video a like? Subscribe to our channel. Hit the bell to be notified of new videos and things that we'll have to help you in your career. And we're going to have some pretty special things coming out. So I'd suggest hitting that bell to be notified about it. I would also say that, download our certifications guidebook and really learn about, which certifications are going to build your portfolio and build your brand. So I really want to go out there and get to that. So there's that. If you haven't, signed up for the free labs, go get those 44 labs or 40 plus labs. I want to make sure you get hands-on as well. And thank you so much. And give me a hashtag AWS while we're at it. That way I know you're here. And I hope to see you all back tomorrow, and bring a friend. Love sharing knowledge. Anna, thank you so much. Pradhan, thank you. Thank you, George. And thank you, Vijay. Prep. You're more than welcome, Vijay, and I'm so thankful you're here. Up and up, so good to see you. And Mark, hashtag AWS, I love that. Romeo, thank you.